जूम पे।
हाँ, जूम
हाँ,
पे।
जूम पे।
I would like to request all of you again to please switch on your cameras for our stream.
I would like
So we will be starting right now. Heartfelt greetings and a very warm welcome to all the dignitaries, professors, and fellow students. I, Tanishka Chaturvedi, along with my co-host Bhagyashree Vijay, would be hosting the most awaited segment of Cyber Cypher, the presentation round. Right off the bat, firstly, congratulations to all the participants who have made it so far into Cyber Cypher. Your hard work and coding skills have all built up to this moment right here. You guys have packed life and spirit into the past 24 hours of this problem solving extravaganza. On behalf of Team Technique, we extend our warmest welcome to all the six panelists who have inspired us with their achievements and thank them for taking the time out of their busy schedules to share this platform with us. Their valuable insights allow CyberCypher to achieve its goal of building a holistic hackathon. It will be with great honor that I would like to introduce them today to our participants. First, we have Saili Shivalkar. She co-founded Neopark Technologies in her third year of engineering. Today, Neopark is working on developing a portable soil testing instrument for large-scale data collection and analysis. She loves complex problems and solving complicated problem statements. Next, we have Dr. Srinivas Padmanabhuni. Bestowed with the title of Eminent Engineer by the prestigious and renowned organization Institution of Engineers, that's IEI, he has secured his BTech from IIT Kanpur and MTech in CS from IIT Bombay. He specializes in AI and is here to bring in a range of intelligence to the hackathon. Next, we have Sumit Sabu, who is first year MBA student at BIT School of Management, BITSOM, and a global winner at Hack Harvard Hackathon, Harvard University 2019. Next, we have Ms. Amrit Kochhar, who is a number one employee at Berryworks and tech advisor at a women's health startup. His current area is focusing on leading things on the tech side while also focusing on the product thinking side. Next, we have Saloni Goel, ma'am, who is currently working at Microsoft. She secured her bachelor's from Virginia Tech. And in addition to being passionate about computers, she has also worked in Wall Street Bank and at a startup in Silicon Valley. Next, we have Ayushi Patel, ma'am, who is currently working as an ML software engineer at Meta in Menlo Park, California. She graduated from IIT Hyderabad and secured her master's from the University of Illinois. Once again, a hearty welcome to Cypher, the pre-event of Technique 14.0, the biggest technological fest of Mumbai. Technique is backed with a rich legacy of 13 editions, holding an extravaganza of tech events over the years, ranging from hackathons to app development programs and gaming competitions. Having attracted rich crowds from esteemed universities, Team Technique strives to achieve the pinnacle of quality to bring out the finest in everyone. And we will be back with Technique's 14th edition this year. The zest and passion we have seen during Cypher are only a peak in the fervor of Technique 14.0. The problem statement for elementary level had been consider two spies that are suspected of espionage with your safe house under constant supervision, establish a medium of communication that prevents any suspicion, and may or may not work on the same device. Overview is that they have to create a tool with which individuals can communicate with one another in a secure fashion. Suggested output is communication can be set up either through command line prompts or through graphical user interface. You are to state any assumptions that you may have made. So we are truly excited to see what our participants have got in store for us. So without further ado, let's begin with the submissions for elementary level. The problem statement for the same has been said before. And our first team is Team DAR, DARR. So let's begin.
So, good morning, judges. Me, Atharva Verma, and Richa Montserrat. We are the team there. So, Radev, will you start the presentation?
Can you tell your team number along with your team name?
Yeah, so we are team 46.
So our question for elementary is, consider two spies that are suspected of espionage with the safe house under constant supervision. Establish a medium of communication that prevents any suspicion and may or may not work on the same device. Next slide. Assumptions. The spies mentioned in the question are considered to be bank employees. The data they are sharing are considered to be bank transaction IDs for the audit verification by the bank supervising authorities, which are actually the encrypted messages. Transaction ID only consists of alphabets or slash or zero. Ideal login credentials for the spies are ID admin, password cyber. Atharva will continue with the algorithm.
Yeah, so before moving on to the algorithm, I would like to state one thing that we have broken the orthodox method of putting forward the algorithm, and we have put it in the way of bulletin so as to make it simple and understandable easily. So let's move forward with the algorithm. So first, we will take the ID and password from the spice or the user. Then the ID and the password will be taken in an input of string. Only if the ID and password entered is right, the program will take the string from the user for encryption or decryption. Now, take the number by which, after that, the program will take a number by which the user want to shift the each alphabet in the string. So let's move forward with the encryption algorithm. So as I have specified, the spies will have to enter a specific ID and password to access the main code. And if it matches, they are allowed to access the main encryption and decryption program. So at first, uh, a spy after entering the ID and password, the spy will enter the message which is to be encrypted. So there is one condition in putting the message, that the all characters in that message should be in the uppercase and there should be no spaces in between them. Secondly, the second output will be in form of number that will determine the order of shift in the character in the string by which the character in the string will be shifted. So after inserting both the string, the message to be encrypted, and the number of shift, the program will encrypt the message by shifting each letter in the string by the given number of shift, as mentioned by the spy or the user. To maintain the uniformity and unsuspicious activity, we have decided to keep the customer ID or bank ID of at least 12 characters. So here we have three cases in which the shifts will differ. If the string has less than 11 characters, the program will automatically add zeros at the end of the string to make it of the 12 character code. If the string has less than 11, if the string has equal to 11 character, I'm sorry, if the string has less than 11 character, there will be a lowercase alphabet indicating the number of shifts. For example, A will specify one shift, B will specify two shift, and so on. Like Z will specify the shift of 26 numbers. So now this is the second case. If the string has 11 characters, there will be a slash at the end of the customer ID or the bank ID, which will indicate that the number of shifts should be 11. And now the third case in which the character in the string exceeds 11 character, then to decide the number of shift, it will be directly equal to the number of string. For example, the hello world. Hello world, the length has 16, the length is 16, and therefore the number of shift will be 16. And the encrypted, after encryption, the code will look like this: XUBBEF. So I hope you understand the encryption part. And now let's go forward with the decryption part.
Hello everyone, this is Dave Pura. I'm going to explain the decryption part of the algorithm. So basically, for the decryption part, the same process of taking the credentials of the user would be the process would go on that way. And when the user chooses that he wants to decrypt a encrypted string, he would have to input the encrypted string. The encrypted string would be inputted and then separated into different words using identifying the space character. Then the program will identify the number of shifts by comparing the last character of the words. Like if it's a slash, then the value to the shift would be assigned as 11. If it's a small alphabet, then it would be similar as previously explained, that A would represent as 1 and then B 2 and continuing to Z would be 26. And then if the string is longer than 11 characters, then the shift would be equal to the length. Basically, that like in this scenario, like the hello program scenario, the length of the string was 16. So the shift would be 16. And then moving ahead, the word that we had separated would now be further converted into another string that would would be present without the garbage values like zero, slash, or any small characters, small case alphabets. The program will then decrypt the latest string by shifting each character in the string alphabetically backwards by the number of shifts derived from the last character of the word or the length of the word. Thus, the decrypted word will be stored in a new string and thus now printing the final decrypted string. Now, continuing with the limitations of the program, the data should always be entered in the capital characters for the encryption. If the length of the string is greater than 10, the shift can't be controlled by the user. Basically, this were the two limitations that we could found.
Sorry to interrupt, but you've crossed
Yeah.
the time limit of 5 minutes. Can you please wrap it up in 10 seconds?
Yeah. Actually, like we had planned to show the code.
Okay,
like,
just wrap it up. That's okay. That's okay. Wrap it up. Just.
Yeah. So that's it. We want to thank you guys for listening to us.
Thank you, team. We could clearly see your hard work behind this presentation.
Just one point before we move on. Right? You listed down under limitations that the first limitation was capital letters. So while you were writing down, why did you not think about this can be handled in your code, right? Like you can just convert something back and forth from lowercase to uppercase using a function, right?
Yeah,
While
but then
writing down the limitation also you could have, sorry, go ahead.
Yeah, so I had that thought to control that way, but like if we did that way, then the thing would have become more complex and lengthier than the current code. So that would have made it difficult for us to explain right now.
And also the last value of shift is in lowercase, so that would be very confusing while decrypting.
Yeah. Okay.
Is there supposed to be a write-up also that we're supposed to look at? Because that's one of the rubric. Was that the presentation itself?
Yes, ma'am. For the judges, it's the presentation, but we have taken the write-ups and all the code as well from them in the form of a Google form. So if you want, we can show it to you later.
Okay, thank you.
Yeah, ma'am.
Thank you, judges.
Thank you, judges.
Thank you.
Make it a point to indicate team number for everyone compulsorily.
Sure, sir. Sure.
What does the criteria column mean?
Sorry, sir.
The criteria column,
not
the first
relevant.
column. That was relevant.
The criteria column is it's indicating the
Okay.
It's like left, yeah.
Yeah. Okay.
So responsiveness, how do we judge? We don't judge, right? Because we didn't see it running. Anyways, there was no UI to judge the responsiveness, right?
So we had made them record their output as well. So I think we will be showing it to you later if you want. I'll just ask my teammates. So I'll call the next team. It's Karan Doshi who has participated solo.
And my team number is 84. So our topic is secure communication tools. So the problem statement which we were given was the two spies are constantly monitored and we have to create a communication tool so that they can communicate very securely and safely. As you know, the information that they have are very crucial. So assumptions, the assumption is that the spy 2, the second spy, knows that to get the secret information, he or she have to put a specific letter in the lowercase as an input. So the working of a code. So a do while loop is used to interact with to make them interact very quickly. The two strings are declared into the input from spy1 using get function, because they can be a larger information. And another string is declared which contains the encryption bank. Encryption bank, it is a set of string which will convert the input into an encryption. So now let's dive into the code. So this is how our code looks. As I said, a do while loop is used, and two strings are declared. The string 1 is AA, and its size is 1100, and the string 2 is B, which is named B, and its size is 1000. A string get function is used to take input from the spy1, which is AA, and encryption bank is also declared, which is named alf, and these are the encryption bank. So a for loop is used, which initialize from the 0 and it is iterates to until the value is lower than the size of AA, and it also the element should not be equal to /0, and it I plus plus. So the new string which will be created will also include the alf and I. So the element with the each element of the input will be converted into an encryption bank, and the encryption bank will be written as an output. But to know the real information, as I said earlier before, that spy B knows how to get real information. So he has to put a letter which is specifically n. Then only the real information will be showed. Mm. Now let's dive into the command prompt. So this is how the code looks in the command prompt. Enter message. So now spy A will enter the secret message. Cypher is the best event. Now as I said, the above message is converted into an encrypted code, and to see the above message, the spy B has to enter a specific letter which is n, as I showed you before. So the real message is displayed, and this is how the encryption even if there is a breach of security, the encryption work as a distraction, so that the person who has breached the security doesn't know what the real information is. So thank you, jury. That's all from my side. Any questions?
Can you go to the code once?
Yes, sir.
So I see you have hard coded stuff. Why did you hard code? Why not make it dynamic?
I don't know that, but I've used the encryption bank such that there is a capital letter and lowercase also, and certain alphanumerics, so that you can get a strong encryption code.
So whatever a message I input, this will be the encryption, right? It won't change.
Yes. No, it won't change.
Okay.
Thank you, jury, for having me.
That was a really interesting approach to the problem statement. Thank you, Karan.
Thank.
Judges, I'd like to have Harsh explain you the rubrics part of this. Harsh, you may continue.
Good afternoon, everyone. So the criteria responsiveness is when the screen is dynamic and it's loading at the same time. When you see buttons on the screen, when you click them, and are the buttons responsive? And on that basis, we judge the project. So that's one of the criteria.
Solutions without
Thank
buttons, it is invalid. It's a kind of invalid criteria.
Yeah.
Okay.
Thank you, Harsh. So the next participant is Kashyap, whose team number is 33. And yes. Kashyap, you may start and you have 5 minutes from now on. Kashyap, I think you're on mute.
Yeah, right. Sorry, my bad. So are my teammates here in the meeting? Hello?
Let me confirm.
Yeah,
Yeah, I'm just confirming. No, they're not here as of now.
They're in the waiting room, I suppose. Akhilesh and Hemant.
Okay. Sure, I'll tell them. Okay.
What's your
Harsh,
team
can you
number?
please add them?
Sorry, pardon?
What's your team number?
Team number 33.
Can we start now? Excuse me.
Yeah, Hemant's time.
We're just waiting for the participants to enter, sir, and they'll just start in a few minutes.
Hemant, are you there? You can start.
I can start.
Yeah.
Good afternoon, respected jury members and my dear friends. I am Hemant Kuswani from Team Phoenix 999, and our team number is 33. This is our story. The story is of Ben and John, who are two spies which are secretly sent for an espionage, and by their agency, which is named as XXS, and are suspected by the government of country YAB for the spying job which they do. They had created a secret way of communication through a specially designed code questioning algorithm. They had created this algorithm for emergency situations for communicating with each other and so that no one can know about it. Next slide, please.
So talking about the algorithm, so as it is the most important part of any code. So first we start the code, then we declare two characters, which is word and the encryption key. So the sender has to put the word, the message which he has to put, and the encryption key as well. So then the process goes like the ASCII of word I minus the encryption key of word I. Then we get an ASCII value which we convert back to a character. And then we join all the characters the computer has. And then the receiver gets a pop-up notification like there's a incoming message. And there's the encryption key is asked to the receiver. Then the if statement is used. So if the key is correct, the decrypted message is shown, and the receiver gets three options then to proceed with. So the first option is to enter a new key and continue. The second is to reply with the same key, and third is to exit. So if the option one is chosen, so the code goes back to the step 3, which is like the encryption of word and the encryption key, the input of word and the encryption key. And else, if option 2 is chosen, then we recall the reply function there. And else, if the third option is chosen, we have the code to be terminated, which is like the return 0 thing. And that's how the algorithm works. So now I would like Kashyap to explain the code.
Yeah. So moving on to the code, the concept of the code basically is if we enter a message, hello world, we take the ASCII values of each and every word, then suppose we give the encryption key, which is dependent on the user, and I'm assuming that both the spies have decided to keep changing the encryption keys based on days or something. So when they input an encryption key, I basically repeat it so that it's more than the length of the word, so that it can be all the characters can be subtracted by each and every element of the string. Then after subtracting the ASCII values, the value which I get, I'm storing it in I'm converting back into a character, and then appending it to a string one by one. So the encrypted messages look something like this. Can I run the code now? Just a second. So this is the structure of my code. So the screen clears and the receiver gets this message. You have a message, encrypted message is this. And we have 3 chances to decrypt the code. So if I enter the wrong number, no, wrong encryption key, then the 3 times the code gets terminated. But if I enter the right key, it shows me the decrypted message and then the actions I want to perform. If I choose reply with the same key, screen clears and reply message, suppose just hello. We'll get the encrypted message like this, which is the ASCII value, which is totally dynamic. We can keep changing the keys every time we want, and then the key is the same for this one since I replied for the same. So hello, yeah, decrypted message. But if I want to change this key suddenly, I can choose option 1, encryption key 345, suppose, enter message world hi. So this is the encrypted message 345, decrypted message. Sorry?
Kashyap, sorry to interrupt. Your 5 minutes are almost over, so can you please wrap it up quickly?
Yeah, that's it. Like that was the code and how it is.
So Kashyap,
This is the output screens. Yeah.
Kashyap, can you change the key to, let's say, a lowercase XYZ? I want to see if you.
I'm sorry, I couldn't hear you. Could you repeat?
Lowercase XYZ.
Is the key?
That's the key. That's the key. Yeah.
Yeah, it will run, but the encryption would not be XYZ, right?
Yes.
Yeah. Enter message hello. So the ASCII values would be non-visible or looking weird. But if I enter the key right, XYZ, the decryption which I did is the same format as totally opposite of the encryption. So it will work.
Correct, because it's maths, but you have not handled the case when the ASCII value goes below 0. The difference is basically negative in this case.
Yeah.
Is what I want to check.
So that's why I basically tried with numbers because with numbers it cannot go below negative, right? Because numbers also with numbers it takes the ASCII value. Yeah.
This is one of the limitations, basically.
Yeah. And also to use the code properly, I haven't done get line. I just put cin for the input so that it will be in one line. So if someone doesn't know how to use this code, they'll get caught immediately. Like the program will not run for the message to get input since it is cin, not get line. Any other questions?
All right, so we don't have any further questions from the judges. Thank you, team. That was a really impressive hard work that you showed us. Now,
Thank you, judges.
yeah. So next up we have is the
Thank you,
team
judges.
Rocket.
Thank you, judges.
All right, so next up we have is the team Rocket, and the team number is 48.
Hi, a very good afternoon to all the judges. So, our team's name is Rocket, and I am Ananya Mishra, and along with Burhanuddin and Shreyas, our project is we have a code that allows the user to hide a string in an image. There are 3 levels of protection: password, the XOR encryption, and hiding the string in the image.
The libraries which we used in this are OpenCV, and we used it in cv2.amread to read the image itself. Can you please change the slide, Ananya? And then we use XOR Cypher for the other encryption.
Okay, so now you can see in our input screen and output screen. I'll explain this once I'm into the code. Okay, so I'll just show the code once. Yeah. So I think it's visible. Once we run the code, it asks for a file name. As we saw earlier, we have we hide the data in form of an image. So over my desktop, I have 2 images, 1 and 2. I'll use this name over here, like 1.jpg. And it asks for a password. So this password will not only acts like an security measure, but in XOR encryption, it also acts like a key, which I'll go through in a moment. So let's set this as anything 854664, let's say. We'll choose a simple and small text because assuming we have spice, so the text will be kept small. So now do you want to see the encrypted image? We'll just see yes. As you can see, a pop-up just here. This is the encrypted image. You cannot see the differences clearly because there's a lot of color over here and the pixels are changed on the top left corner. I'll use another picture in a moment to clear it. Once we click yes over here and re-enter the password, that is 8564, we can see our original message over here. Now going on to XOR Cypher method, we'll just use a simple example over here. As you can see, I have 2 variables, 5, 4, and I'm using the XOR logical operator. Running the code, we have 1 as the answer. This 1 will in our program is stored as the encrypted value. Now when I change this 5 with 1, that is our encrypted value, keeping the key same and run it again, it shows 5 again. That is our original message. That's been used over here. So what we do is first take the input, convert it into an encrypted form, and upload that encrypted form to an image. Now to show the working, I'll just change the image taken over here to, let's say, just a second. Okay, running the code again. So the first case I used 1.jpg. I will use 2, same password, or let's change it, 7894.
Okay, I'm sorry to interrupt, but Amit Kochur's judge has told that we cannot see the image pop up. So if there's anything like that, can you please elaborate?
Yeah. I'll show the image pop up just a second. I'll reshare my screen. Maybe there's some error or something.
Okay, thank you. Okay, I think it would be visible now. Extract data from the image, yes.
The password was 7894. So this was the image pop-up. Over here, I have used a blank white screen, so I can show you exactly how it is storing the data. I'll zoom in, come to a corner. Just a second. Over here, you can see a line of pixel is changed. This is a very slight change, and as you can see, I'm in maximum zoom. So to a naked eye, this is not visible. This is the encrypted image, secret image 2. And for the original image, we have this one. This was the original image. As you can see, I'll zoom in fully and scroll to top left. You can see there's nothing over here. So through this, the chances of getting caught while sending a message is minimum. And over here, we could see it because it was a blank white screen. If you use an image like this, which I used in my first trial, it's very hard to even see the image, even if we zoom the maximum. You want me to show the first one again, jury members?
No, I think it's okay.
Yeah, okay. So that's all the code. Now going back to the presentation to end it. I'll stop sharing. Yeah, so scope of improvement. We thought that taking images over here, we used 2 images only, and that were already downloaded in my system. I think it would be better to take image from the user, like adding a whole file to trace it back. And also we can add a couple more layers of encryption, because why not? More security is always good. And we have to type all the things in. Adding a GUI would have made it better. And one more thing that we noticed right now was that we can add a way to share this image to the second person directly, so that they can decrypt it at their end, and the let's say the process is more secure. And while transferring the image, we can encrypt that image as well. So this third party cannot access it anyway. So yeah, thank you. That was our code.
What's your team number again? Sorry.
Team number 48, Team Rocket.
Judges, once you're done grading, let us know so that we can tell them to leave.
Good work, guys. Good suggestion. Obviously,
I think speed has to be increased. I think how many more are remaining? This is very slow.
Yes, so okay, we'll increase the speed. Team Rocket, you can leave. Next up, we have is the solo participant, Manav Moti Ramani.
Hello.
Yes, Manav, you may begin. Just note that you have 5 minutes to present.
Yes. So my team number is 88, and the name of my project is Flappy Bird. So the problem statement which was given where we have to establish a means of communication between 2 spies such that no one would suspect them. So the technology which I used in this project was Flutter and Fast API. So Flutter I used is an open source UI software by Google, which I use for the front end. And Fast API is a RESTful, with the help of which we can create RESTful APIs in Python, which I use for backend. So when we look at this image, most of us are confused what exactly this is. So this is Morse code, and Morse code is very simple. We can represent every letter in English with just dots and dashes. So Since the name of my project is Flappy Bird, I have created a game which is Flappy Bird itself. So the user enters the name, which is basically the name of the file, and then so I will explain later. So this is so the game instruction is such that the user so anyone if there is someone who sees user playing the game, for them it is just a Flappy Bird game. But for actually a single tap which the user does represents a dot, a swipe represents a dash, and a letter space is space and word space is slash. So I will just show the video demonstration now. So the user enters their name, which will be the name of the file. So for here, it is, for example, day2. So the name of my file will be day2.txt. So since we don't know Morse code, I will be using this Morse code translator. So for hi, so H is 4 dots, and then the next letter, then I, which is 2 dots. So I will make that with the help of this game. So I tap 4 times. And then since next letter, so I click on letter space. So this is for video demonstration only, letter space and word space, which will be replaced by cancel and drag again. Letter space, and then I tap 2 times, and this is I. So onto my fast API, which I have hosted on Heroku. Over here, since I've written day2, so my file name will be day2.txt. And I execute, and I can see I have 4 dots space 2. So I will be using an online decoder. So over here, I got hi. Similarly, for since next word, so it is a slash, so I click on word space. And then again for H, I tap 4 times. Can execute and you can see a slash and H, that is 4 dots. So I go ahead and write a big sentence with the help of this game. This is my Morse code, and I will just decode this. This is what I got. So the only assumption I'm making is that the spies know Morse code. And this was my project. Thank you.
That was a mind-blowing presentation. Judges, if you have any questions, please ask them.
$28, right? No, 38, 28.
88 team
88.
number.
All right, so thank you, Manav. We'll move on to the next participant. It's a solo participant, Yatharth Agarwal, team 113. Yatharth, you may begin, and just note that you have 5 minutes for your presentation.
Okay, I just share my screen. Good evening, good afternoon, everyone. I'll just start with my presentation. So, my app name is Chat Server. Then the question for this year Cyber Cypher is considering two size spies to prevent suspicious and data that are very secret to people. Then so I made two different parts for it. One was the server.py and the other part was client. Whereas in the server, I have written the code where the server will connect to the client to send messages after the binding and after securing them. So I will show you the output after after the client py. Then in the client py, the client will connect to the server, and then after they are connected, they will like the server will encrypt the data, and then the client will decrypt it and show the message. So going to the output, this is the server.py. This is the output. So first we need to take the host, like the host. When we take the copy the host and put it in the server and enter the both server and the client will be connected. So the server can now send a message. So hi judges, like I have put. So it will go in the client one and see hi judges. So now server can client can write anything. So it will be in a flow. So to explain it more properly, I have a presentation for you guys. Hello, what's up, people? Yeah, so today I am going to start with my new project. Like, I have made up one project for the chat room, for a safer chat room for some people like who need to chat in personal or doesn't want anyone to see. Yeah, so this is the code for server, as you can see that, and this is all the data in it. Like, server starts with the host. Binding is completed, but we are waiting for incoming corrections. This is the client one. I have made it in two different desktops, like two different screens, so that it can be a better one to get understandable and see how it works. So yeah, this is the host name. Enter, connected to chat room. Over here also it is connected to the chat room. So we can say, hey, how are you? Enter. So like when I wrote here, it came here. Hey, how are you? So I say, hello, I am fine. Thank you. How are you? Enter. It will say, hey, I'm fine. Thank you. So thank you, Judy, and this is the end of the presentation.
What exactly is the encryption technique used? That's not clear at all.
So actually, I have used the connecting address and all. Like it will. I have used the listening part and that connect comma address. So when like if a server is connected to send data, so it will the message over here will encode it, and then over in the client part it will decode it. Over here, incoming receive message, it will decode here, and the server will then like the client then print the message that the server is being sent, and then it will happen in loop. So I have used a while loop here. So for that.
What is the team number again?
113.
So thank you, Yatharth. That was a wonderful presentation. You may leave now. Now, next up, the next participant is Rishika, who has participated solo, and her team number is 112. Rishika, you have 5 minutes from now. You may begin.
1 second. Okay. So good afternoon, Judy and everyone else. My team number is 112. I'm Rishika Gade. So I'll just share my screen. Okay. So basically, for the question given yesterday about the two spies, my approach for it was in a way of diary exchange. So it's more like in person. If you see one person, if they want to enter any message or anything in a diary and they pass on that diary to another person, so they can read the previous message and they can write their own reply to it. So I have written the code in C language in C code blocks. So I'll just show you how the output and how the code runs, and then I'll show you my code. So in this, suppose spy 1 wants to enter a message for the spy 2 to see. So the program start and they have to enter a pin that those two people know. So, and if they enter the wrong pin, then they will have to, they will get 2 more tries left. And once they enter the correct pin, they can access the chat. So now they get the option if they want to enter a new chat, a new message, or they want to look at the previous message. So here Spy1 said that they want to enter the new chat, and they said red. So suppose it's a code that only those two people know. In that way, it will be more secretive. And here for Spy2 to operate it, they will again, that person will also have to enter the same pin that Spy1 had to enter. And then here Spy2 wants to see the previous message entered by Spy1. So they can see the previous message was read and the Spy1's reply was only okay. And that's the end of it. So this is basically a very cut short method in order if they want to save time. Okay. So now in the code, basically I have written 3 functions. The first function is for the user access, where I have already given them, where they have a pin to enter from the start only. And if they enter the wrong pin, as you had seen before, then they get the option to enter it 2 more times, and they even get a hint, which is basically what again only the two people can relate to. Sorry. And then in the second function, we basically it's basically about how the message is going to be entered. And for the message to be stored, I have opened a file, and yeah, so and then again here we give the conditional statement for it. If they enter an O, so that means they can enter a new entry, and if they enter an X, so they can see the previous message. And this function is called upon in the user access function. That is when they enter the right pin. And the main function is basically just calling the user access function. That's more of it. And for future updates, so basically we can add in more login questions so to make it double secure. And currently the program only works for one login or one user, basically like one team. So if you want to enter more teams and stuff, so that we can add in later on. That's basically what my program is about.
How will the second spy know what is the pin that he needs to enter?
Sorry?
How will the second spy know what is the pin that he has to enter? Now you have used a fixed pin, right?
Yeah. So that is that we can again modify later on in the code if you want. But for now in this code, it's more like the two users, they already have something that they relate to. So if the two spies, they already might have been given briefing or something beforehand. So that's my assumption, that they already know the pin. So they both can access the messages entering the same pins.
But then since they're spies, shouldn't they be using a different pin every time to maintain the secrecy?
Yeah. Okay. Makes sense. I'll keep that in mind next time.
Yeah.
Any other questions?
All right, so that was an amazing presentation, Rishika, and you may leave now. Thank you for your time.
Thank you. Thank you so much.
Next up we have is team semicolon coders. So team semicolon, you have 5 minutes from now on, you may begin.
All right. Good afternoon, jury. Just a second, I'm sharing my screen. Okay, let's just start with the presentation. So, can you see the screen?
Yes, it's visible.
Okay, our question was same as everyone else. Consider 2 spies that are suspected of espionage with the safe house under constant supervision. Establish a medium of communication that prevents any suspicion and may or may not work on the same device. Create a tool with which individuals can communicate with one another in a secure fashion. So what we have done is we are using symmetric encryption, which basically means there'll be one common encryption key between both the spies. And this key can, so initially in our code, we made a code to generate a new key every time. However, that was getting very problematic as we are using one of the libraries called Fornet, which uses a 2-part encryption key, a 128-bit AES encryption and a 128-bit SHA-256 encryption key. So this key was actually very long and it was very difficult to copy and send it to spy2 every time. So what we did is you can generate the key and you can generate as many keys as you want. And once you generate a key, you can just put in the key and hence the communication will go forward. For the communication part, we are using another API called ThinkSpeak. It's basically an API where we can post strings in a JSON format and then access this from our reader. So our program is a 2-part program, a sender program and a reader program. And again, we are using the same Fornet library to decrypt. And I have made a very simple GUI for it using Tkinter. So my program looks like this, the image you can see. And all you do is basically you put in whatever text you want and you put in the encryption key and the program goes forward. So I'll just explain what sender.py does. Initially, we were initializing all variables and also the Kinter window. After that, this is where the encryption takes place. This is my encryption function. What is happening is we get the message, the raw input from the entry box, and then I also take the key from the entry box, and hence we use the key to encrypt it and then push it onto the URL, which is on ThinkSpeak. We have used my own API key over here, and this basically means the server is also hosted through your own API key, which again, it even reduces intrusion even of the encrypted data. After that, this was some more code for the Kinter GUI. And then we come to our receiver.py. In our receiver.py, you enter the key and you click on decrypt and read. This basically accesses the same URL. It takes the JSON file. And then we convert the JSON file into a string because the JSON file format was different. And then again, we decrypt the message. Before decrypting the message, I have to convert it to bits because Fornet tokens only work with bits. And after decrypting my message, we display it. And this is again my Fornet library. I'll just share the program now. Okay, I'm unable to.
Bhavya, you left with just 1 more minute.
Yeah, that's fine. I just have to show my program. You can see my screen?
Yes, it's visible.
Yeah, so I'll just use a website to generate a Fernet key. That's a 2-bit key. I take the key, I copy it. I go to my sender file. Over here, I can put in any text I want. Suppose, hello, judges. So there's no limitation to this being just one, it can be a string. And then I enter my encryption key, encrypt and send. So this is what the text is sent to my server, like that, my ThingSpeak API. And this is the key. So I'll just copy the key again. Now I open my receiver.py. Over here, I enter the key and decrypt and read. Over here, the message updates. All right, that's all. Any questions?
How is the information being shared between the two scripts?
Sorry, could you repeat the question?
So how is the information being shared between the two scripts?
So it is shared between the two scripts using a ThingSpeak API. It's basically an API where we can upload JSON files. I take the message, I upload it as a JSON file, and then I upload the JSON file. Then I access it from through the other script. And they are both using the same API. So the same server hosting is being used. So we can run this off different computers.
Sounds good. Thank you.
Any further questions? All right, I'd like to wrap it up.
Okay, that was a wonderful presentation. Thank you, Bhavya. You may leave now. Next up, we have the solo participant, Hisham Supariwala. His team number is 117. Hisham, you have 5 minutes and you may begin now. Hisham, if you're saying something, we cannot hear you.
Am I audible now?
Yes, you are audible now.
Okay, sorry. Okay, so I've created such a tool in C++ by which two spies can communicate with use of encryption. So I've used ASCII codes for this. So like I've used ASCII codes when the user inputs a string, inputs a sentence. So using a for loop, I extract each and every character and then change it to their respective ASCII code. For example, ABC, A65, B66, and C67. So it depends on the user what to do next right now, because during the ASCII for the ASCII codes, it will be 65 plus some value for the encryption. So the user will put how much the difference should be there. Like for example, 65 plus 5, that is 70. 70 is some other variable. Like that for the same thing, 66 plus 5, 67 plus 5. And now for the decryption part, where the same after the encryption is done, the input has been changed to null because we don't want anyone to take the input. Only we have the encrypted format of the sentence. Now for the decryption part, when the decryption it takes place in the same way, like for the ASCII code, but instead of adding, it just subtracts the value, the difference which is given by the user. But now for getting the decrypted value from to the receiver, he will have to put a code, and the code every time the code is generated by the user, and the sender has to give the code directly in the message. Pros and cons, the message encrypt. Pros, message encrypted. My code is really simple. I didn't try to complicate the code. And we can add more encryptions in the future. The input message is deleted immediately after the encryption takes place, which is the best thing about the code. The cons, the difference in ASCII code can be known very easily. For example, ABC, I've added 5. What if the person receives a text, they put some password randomly, they receive the text, they figure it out. But every time the ASCII code changes by the user who's sending the message. So there's a solution too for this. In future updates, you can add a GUI, increase the encryption level. We can add a video message or a voice message also, and add maximum encryption to it. And we can even add a reply feature. For now, there's no reply feature in it, but you can resend the whole message. Can I show my code? Okay, so this is my code. I made 3 functions: a main function, decryption function, and encryption function. In the encryption function, it is extracting each and every character of the string, changing it to the ASCII code, and then adding the B is the difference in the character, the difference in the ASCII code. So just adding it up here. Decryption is the same thing, but just subtracting the ASCII code part here. The main function, we are taking input from the user. The code is a password here, and see, this is the whole code. Once the encryption takes place, the input has been changed to null. Then comes a part where the user will put the code, the password, the receiver. So if he puts the password correctly, he will directly get the decryption message, which is over here. Else, if he does not put the password correctly twice, if he does not put the password correctly twice, then the sentence will get vanished. Even the encrypted message will get vanished. It will be changed to null. See, I thought of doing it thrice, but twice is more than enough, because it should be maximum encryption over here. First time, okay, many people can do a mistake, but second time, after the mistake, if someone doesn't want to repeat the mistake, he will check thoroughly second time. So that's why I did not want to put 3
Sorry
parts
to
over here.
interrupt. Your time is up now. So can
Just
you
a
please
second,
wrap
I'll
it
just
up?
show the running. Yeah.
Yeah.
This is the code. I'll enter a message. Hi, how are you? The difference is the difference in ASCII code. For example, I'm putting 5 over here. Now the password that the receiver has to enter. I'll keep the password of 123. Now this is the receivers and the password that access. Now I'm the receiver over here. I know the password 123. I got the message. I'll show it to you all. What if I put the password wrong? I'll keep the difference as 7 over here. Receiver password 123. Oh, sorry. I'm really sorry. First time I entered the wrong password, re-enter your password. Second time, put the wrong password. The message has been deleted permanently. Okay, I'm done.
Okay, that was a great presentation. Judges, if you have any questions, please feel free to ask. So no questions. So Hisham, you can leave. Thank you so much for your time. Next up
Thank
is
you.
a solo participant. His name is Varun Singh, team number 65. Varun, you have 5 minutes from now on. You may begin.
A very good morning, jury. Just a second, I like to share my screen. Yeah, hi. So my name is Varun and I'm from team 65 and the language that I've used is C++. So the assumptions and the limitations, I like to show it after I present my code, if that's all right to the judges. So going on, I'll just show you my code. What I've done is, instead, since we had to maintain a medium of communication that prevents any suspicion, I tried to make the code into a game form. So basically, it gives you 3 options, whether you want to play a maths game, a Flappy Bird game, or you want a BMI calculator. So if you would enter any option from that, for example, for the Flappy Bird game, it would just bring you to the menu here. And if I had to play it, that would be very simple. and that's how it's done. But if here the favorite number and the key to victory are the important highlights, because I've made the assumption that both the spies are British, but here they have used American English for the word favorite without the U, and that is what separates their communication skill as of now. So the favorite number here refers to the house number for the spy that the message is being sent to, and it is 63. And the key to the victory is the secret key that is common to the organization. So if I were to enter any key randomly, it would be like 58. It would show me a warning that 2 tries are remaining. If I were to enter another wrong try, for example, 65, a single try remaining. So the secret key is 47 here, which would take me to the next menu, whether I want to encrypt, decrypt, or quit. So if I'd like to encrypt the code, it would be, lead me here. And if it's if I had to encrypt this, it would go ahead and be like, yeah, this is the encrypted code. And if I had to decrypt it again, that is the second if I had to decrypt it, I just enter the right key right now. Yeah, this is the decrypted code. But if someone were to exceed the number of tries, that is, I've entered 2 wrong tries already, and the third try I enter again wrong, that is not 47, for example, 98. It would say the maximum tries exceeded and data deletion initiated. So as of now, the assumptions I have made, I told you, the spies are the British, the favorite number is the house code, the words favorite number and key are used as hints, and the key is common to all the agents of the agency. I have used basic day-to-day applications to not let the suspicion grow. And the favorite number is entered by a person only has 3 tries before data deletion. These are all the snippets for my code. So, the future additions or the limitations would be like we could use file handling and the binary stream for input storage, and also the deletion of data if the number of tries were exceeded. Shifting it to a Flutter or Android Studio for app development would be a great progress to this code, which wasn't possible as of now because I use the language C++. Encrypting files and folders and not just text, just like Team Rocket suggested earlier, would be a great benefit to it. And the games that I showed, like Maths game and the Flappy Bird game, were kind of basic. So adding a more complex game that requires a certain skill, and in that game, the key panel would only open if a certain pattern of missions were to completed, and that pattern wouldn't be linear. It would be very complex. And again, increasing the complexity and the layers of encryption would be great. That's it from my side. Thank you.
I like the flow of thought, Varun. Good job there.
Thank you. Should I stop presenting right now?
Sure. If the judges have any questions, please feel free to ask. Okay, so no questions. Then that was truly an impressive approach, Varun. Thank you so much, and you may leave now.
Tanishka.
So next up we have is team Demonic Compiler, team number 45. Team Demonic Compiler, you have 5 minutes from now on. Have they entered yet? All right. So Team Demonic Compiler, you have 5 minutes from now on. You may start now.
Ma'am, one of our members isn't in the meeting. Can you let her in?
What's his name? Harsh, please just admit that person. Can you
Bhavi Mistry.
He is not there in the meeting. Darsh, can you please admit him in the meeting? Bhavi. Okay, so he's not there in the waiting room as well. So I think you should start now. Rishabh, will you be starting?
Yeah, just a sec, just a sec.
Yeah, sure. We have a time crunch of 5 minutes, so please. Start.
Yeah.
Ma'am, actually, the one who was going to screen share isn't here because she isn't in the meeting. It's saying that waiting for the host to let her in the meeting continuously.
He's not there in the waiting room. If you could just call that person, you'd be losing
Yes,
on
ma'am,
time.
calling.
Yeah. All right, Bhavi, you're here. You have 5 minutes. Kindly make it as fast as possible. And all the best.
Sorry, judges, to keep you waiting.
Bhavi, are you starting? I can't see her. So
Yeah, just a minute. Good afternoon to all the judges present here. So our team number is 45, and today I'm accompanied by two of my team members, Rishabh and Parth. So our topic is that consider two spies that are suspected of an espionage with the safe hosted under constant supervision. Establish a medium of communication that will prevent any suspicion and may or may not work with the same device. Before starting with the explanation of the code, I would like to give a small brief about ciphertext and plaintext. Ciphertext is basically the
Bhavi,
encrypted. Yeah.
Really sorry to interrupt, but your screen isn't visible properly. So, like, can you reshare the entire screen if possible?
My entire screen is shared. Just a minute. Wait.
We can just see a strip of screen.
Is it now visible? Yeah, I'm
Yeah,
sorry.
continue.
So the difference between ciphertext and plaintext. So ciphertext basically means your encrypted text, and plaintext is the decrypted text. Now over to you, Rishabh.
So here for
communicating between the two spies, we hosted a server using that socket module, and we have made an assumption that both of the spies know the encryption key beforehand, which will be prime number in between above listed ones, and then there's those two functions which perform the encryption and decryption.
Then the sender will receive the function and connect it to the same port, and here is a statement: data is equal to receive 1024. It decodes the message and sends it to the client, and the decoding is done in bytes.
Here are the output screenshots we put for the server, as in the spy1 and client being the spy2. So first, the server has to host as in the server on its device, and then after that, the client running the code, it asks the client what message he wants to enter. We put good morning over here and ask for the encryption key, and then it updates the screen for the server asking it for the decryption key. If the server enters the same key, then the decryption happens and it shows the message. Same vice versa.
Okay, so now I would just like to run and show you the code once.
Oh, you left for just 1 minute, so please make it quick.
Yeah, I'll just want to run and show you the code. Okay, so now I have imported two files at import server, and the second one is your client. So now while importing, just a minute. Server, now I'll press enter, then the host will come. And now on the server side, message to send, and I'll give a message saying good morning. It will give me a key for inscription, and I'll write as 19. Once I'll enter the message, the first spy will be able to see good morning. Thank you so much. And I'm really sorry for keeping you waiting. Thank you so much. Any questions?
Just one quick question. What happens if I don't enter a prime number?
Bhavi, are
The
you saying
program will
something?
stop working. It will show an error. That's right. And for future, we will like to add Morse code for it, because we don't know much about it, and have longer conversations, because this conversation, the code we made, it only works for one time, vice versa. Yeah.
Thank you, team. That was a wonderful presentation, and you may leave now. Thank you for your time. Next up, we have is the team Bugbusters, team number 10. Bugbusters, you have 5 minutes from now on, and you may begin.
Can we start?
Yes, sure. And you have 5 minutes.
Can
so
you
please
repeat your
begin.
team number, please?
Team number 10, so.
Okay, so good afternoon, everyone. This is Ishika Jain from Team Bugbusters, and my teammates consist of me, Rishita Mantri, and Adi Mathur. So this was the problem statement that was given to us. The softwares that we have used in this presentation are as follows. We have used VS Code, C++ library, and Canva. So the concepts that are used in the code are strings, bits, functions, for loop, while loop, vectors, getLine library, string stream, and concept of ASCII code. From here, Rishita will continue.
Okay, so how we understood the problem statement and how we approached it. So basically, two spies are having a very confidential conversation on a device and they don't want any third party to know about that. So after reading the problem for the first time, we interrupted that from the question that we'll assign some values to all the 26 alphabets. But then we came up with that we'll divide the 26 alphabets into two parts, 13 and 13, and we can assign values as A is equals to Z, whereas Z is equals to B, and so on. Later, we thought that we can assign values to vowels like A, E, I, O, U, and this will make our code much more easier and also very upgraded version of our previous code. So, but the exception here was the words which do not consist of vowels like shy and myth. So when we realized that why we should assign the values when you can use the ASCII code, so we started working on a code using the ASCII values, and every single bit represents a unique character, and hence we don't need to assign certain values to the character. Now from here, Adi will take over.
Thank you, Rishita and Ishika. Please, can you change the slide to the coding one? Okay. So, hello, myself Adi Mathur, and I will explain the code. So, what we have done here is we have used the bits library. So, means we have used the concept of tokening. Here we have defined a string, function string encrypt, and in that the parameter string word. Now we will initialize the string first, and again we have defined a character variable ch, in which we will store all the extracted word. Means our basic idea is that suppose a sentence is there, so we will break that sentence into words. Means the basic means what we call as tokening, and we will store that in the ch. Now we have applied for loop for counting each alphabet and convert them into ASCII code. Suppose my name is Adi. So the length of the word for my name is 4. So as we go I equals to 0, I is less than 4. So it will go inside the loop. Now here it will count at location 0 A, and it will like ch में A store हो गया. Now A के लिए ASCII code होता है 97. So 97 minus 64, it will be 33, which is a ASCII code for exclamation. So it will store exclamation in new ch. Means whenever I will type Adi, so first two letters double A, it will be exclamation and exclamation. So means we are step by step converting my name into a code. And we will here return it will encrypt code. Now we came to main function. So here we have defined a string variable str, we have created. So if enter the message, he or she typed the message, created a while loop for that, so that we can continue the conversation till we want. Like int counter equals to 0. Now while counter equals to 0, it will count the counter 0, so it will go into the loop. Now here it will count enter your message. So we will enter our message and get line. Get line is used to get input from the string. Now, now again in if condition we have applied ki if the two person wants to stop the communication, so it will just we have to press the E key, so it will counter 1, which is not equals to 0, so it will not go inside the loop and break will be applied. Now if I am going to run my code,
Adi, your time is up. I'd request you to please wrap it up quickly.
Yes, I'm just showing the output. Suppose, can you hear someone is outside? So it will just go to the code. Now here our assumption is that ki jo dusra person hai, the other person can understand this code. This is our assumption. He knows the knowledge of ASCII code and he can understand. Again, he will type something to first person like, yes, I know. Like that conversation will go on, and when they want to exit, they can press just E. It will counter 1 and break will be applied. Thank you.
Thank you so much, team. If you have any questions, judges, then you may please ask them.
No questions. That's
all right, no questions. Thank you so much for your time, team. And you may leave now. Next up we have is Team Air, that is team number 44. Team Air, you have 5 minutes from now on. You can start now.
Yeah, is my screen visible?
Yes, it's visible.
Okay, check. So a very good afternoon to you guys. Very good afternoon to you guys. So I'm Rishabh, and I have my friend Rimansh with me here. We are team A and team number 44. So the problem which we were given were to create a tool with which two individuals can communicate with one another in a secure fashion. Okay, so like the assumptions which we have made with the two individuals. So the people supervising the spies, which are the two individuals, are just observing them from a distance and have not confronted them yet. Okay, right. So and the second one is like, or we have taken the worst case scenario, right? So all the messages and texting applications are like blocked by the supervisors on the network at their home. So they are in the same home, right? So both the spies, and the third assumption is both the spies have their own PCs and the PCs are on the same network. Okay, so like what we thought, like for this question, since the spies are under the constant supervision, they will communicate in cipher text using their PCs through the command prompt. Okay, so they'll use our algorithm. Each spy first encrypts the message using our encryption algorithm and then sends the cipher text to the other spy species using the command prompt. So okay, the command prompt makes the work easy because it is basic, and the doubt would never go on it. So the second spy uses our decryption algorithm to decrypt the message, right? So yeah, now Ramesh, can you please go ahead?
Yeah, sure. Good afternoon, judges. So now I'd like to explain you the encryption algorithm. The next slide, please. Yeah, so here I present the encryption algorithm. So the whole code is written in Java. So basically, this is no standard algorithm. So the algorithm starts by just reversing the whole message, and then it traverses through each of the characters, and it checks if the position of the character is an even number, then it increases the ASCII value by 1, and if it is an odd number, then it decreases the ASCII value by 1, and then the function finally returns the string. Next slide. So here is a sample input output where the message was the suspect caught me eating snacks late at night, and the sample output is present as below. And the bottom photo is of the terminal. And yeah. And then here is the description algorithm. So basically the description is basically the mirror of the encryption algorithm. So we start off by checking if the position of the character in the string is an odd number, then we increase its ASCII value by 1. And if it is even, then we decrease it by 1. And then finally, we get the deciphered text, decrypted text by reversing the whole string. And yeah, to the next slide. This is the sample input output. So we've just copied the output from the previous encrypted text and we got the same output. And yeah, and now I'd like to call Rishabh to explain the chatting using command prompt.
Yeah. So the most important part of the process was how the both spies will communicate. So we thought of it, and the simplest thing which we could get was like they can talk using the command prompt using their IPs, since they are on the same network. So like I have basic steps like how they can create, the BAT file, messenger BAT file. So I'll be explaining it to you. So like you just need to open command prompt on your PC and type the following code. Okay, so what this does, after you have finished it, you can just save it with any name with the .bat extension. Okay, then what you have to do is go to the control panel, go to the administrative tools there and click on services. So, in the services section, there will be a messenger service in that list. You need to open it. And after that, you need to just press the start button. Okay, and you have to do the same procedure on the other spice PC too. Like if you haven't done this, then the feature won't work. So that
Sorry to
makes it
interrupt,
much
Rishabh.
secure.
Your time is almost
Yeah.
up. Can you, like, I request you to kindly wrap it up quickly?
Yeah. Cool. So this makes it more secure. So like the final thing to do is you just need to click on the file which you have made it and enter the IP address of your fellow spice PC, and just you need to like text him the cipher text using our algorithm which you have converted it before, and he can just copy the cipher text and decipher it using our algorithm. Yeah, so thank you. Like if you guys have any questions.
Okay, so if the judges don't have any questions, we can wrap it up. Thank you so much, team. Thank you for your time. You may leave now. Next up we have is, yeah, sure. Next up we have is Team X Spark, and that's team number 57. Team X Spark, you have 5 minutes from now on, and you may begin now.
Yeah, am I audible? Yeah. So good afternoon, judges. Just a second. Yeah. So I am. Yeah. So we are Team Xpark, and our number is 57. And today, me and my friend Dhruv, we are going to take you to a Discord server. Yeah. So what's all our project about? So there are few just a second. Yeah, so there are few professions which need a secure communication network to maintain a secrecy on the job. My just a second, just a second. Yeah, sorry for the inconvenience. Yeah. what all is our project about? There are few professions which need a secure communication between them. Few professionals which need a secret communication language between them to maintain the secrecy of their job. So my project is we have made a Discord bot which you can communicate with the two spies in a secured way. So our project mainly focuses on establishing a communication medium between two spies who are under constant supervision. So here, how it works like this way: the spy one gives the message hello, the spy 2 receives its hello, but the middle person or any other person will receive it like this way in an encrypted message, so he can't understand anything. And we have made our code such that if after 3 times the code randomize this code, and it would have a different meaning. So if the code after 3 times puts this uh, encrypted message, he will get something else. Yeah. And how the communication works like this way: encrypted messages, Mr. X puts the message like this way, so the other spy need to decode it by putting some key commands, and he will get the message like victim is spotted on alpha. And the same way, if team Mr. the second spy puts the coded message like this, he would the same goes on, and they can communicate with that. So this and video by Dhruv. Is the audio visible? Audible?
No, we cannot hear it.
Okay, I will just show it rather than. So these are all the URLs of YouTube link and GitHub where we have uploaded our code. And thank you. I will just show you. Just a second, we'll show you how it works.
Okay, sure.
Yeah. So this is our server. Yeah. Yeah. So the spy, suppose we are assuming like this creeper is spy 1, which is actually Dhruv. So he has messaged and an encoded message. So I can I need to decode it. So I need to write #decode, and this is a password set by us. So only the other spy would know the password, and he could only decode it. We need to just copy paste this one, and we could just enter. And I will be able to, just a second. And yeah, so the encoded your key is in. Okay, sorry. So yeah, we'll just encode it once and decode it once again. So encode hello. You just have to decode it. Yeah. Okay.
So just #decode and then the key and the phrase you wanted.
Yeah, and then this about code x6 #6 c $2f xma. Yeah, and then enter. Yeah, so I got the message like over and out, and in the similar way, like this way, I can also encode the message, and the Dhruv can also receive it. And we also can make it like #encode if we want only Dhruv to see that message. So #encode.
Nina, your time is up. You can please wrap it up now.
Yeah, just a second. Yeah, so #encode just a second. Epic translator.
Just send it to yourself.
Yeah, and then I will send it. Yeah, so the bot will revert to me and the decoded message. So thank you.
That was a brilliant explanation. If the judges have any questions, they may please ask. Okay, so no questions. So Thank you so much for your time, Nile. You may leave now. Next up we have is Team Lali, and the team number is 22.
What's the team number for the previous team?
For the previous one, just a second. 57. Team Lali, you have 5 minutes from now on, and you can start now.
Yeah, okay, sure. Good evening, judges. So we are Team Lali. I'll just share my screen just a second. Is my screen visible?
Yes, it is.
Yeah. So yeah, we are Team Lali, and I'm Lakshmi, and I have another team member, Lipsha. We are team number 22. So whatever technologies we used is HTML, CSS, JavaScript, Node.js, and socket.io. We have used the SHA-256 algorithm. What is all about our project is we are assuming that spies are trained to understand the SHA-256 algorithm. And in our chatbot, the messages are encrypted using this algorithm. As this algorithm is like 256 bits long, so we decided to take a substring of 15 characters so that it will not be long and it will be easy for someone to realize and recognize it. So some keywords such as alert, terminate, found, begin, killed, etc. These for these keywords, the spies are already trained for the encryption thing and the decryption thing. And also the another feature what we have added is once the spy reads the message, and after 30 seconds, the message gets disappeared with an audio saying the message has disappeared. So I'll show you the demo for this. Here, this is the landing page. So we have to just enter a username, suppose ABC, and we have to select any one room 1, suppose. Can you see my, is my site visible or it's still in the presentation?
It's on the presentation side, yeah.
Okay, I'll just share it again otherwise. Yeah, now screen is visible, right? Yeah, okay, so we have to just enter here the username, then we have to select any one room type. Suppose I'm choosing room 1, and if I click on join chat, then it will say one encrypted message will come. And here this is an SHA-256 algorithm, which we have taken as a 15 substrings. I mean, from the 256 characters, we have taken a substring of 15 characters. Suppose I write here a message, suppose about or something. The message gets displayed, and for the communication between two users, suppose I here open another one, and I go with the message has disappeared, and I here join with XYZ. So this message is for somebody joined a chat or something, and you'll see after 30 seconds the message will disappear, and then audio will just come the message has been disappeared. The message has disappeared. Here it came, the message has disappeared. So now if you leave the room, then it will show the user left, and in the user panelist you can also see the ABC is not here. So now if I do it like ABC, and I'm in room 1 and I join the chat, and if I open another one and I join with room 2. So I just want to say you that the room 1 members cannot see the room 2 members, whatever they are talking about. So it's one group went for a mission, and they are the people who went on the right side, they can go to the room 1, and the people who are on the left side, they can go to the room 2. Yeah, we approached in that way. So yeah, that's it. The message has disappeared. Yeah, I'm done. Any questions?
How is the decryption happening, or do the spies know that already?
Yeah, that's what I told, right? The agency teaches them that this word, when you see this thing, then it's for this message. They're not allowed to use some other words. They're just allowed to use some specific keywords. They can use alert, terminate, begin, star, and like that, found, killed, or something, etc. Like those. I know that it's possible for someone to remember the whole 15 characters. They can just remember the first letter or last letter or middle of some middle letters. through which they can recognize, oh yeah, that's the word they are saying. The best part is like it gets disappeared. So if somebody else has this thing also, they won't recognize it. Okay, what was the message?
Got it. Thank you.
Yeah.
Thank you so much, Team Lali. That was a beautiful presentation, and you may leave now. Next up, we have as a solo participant, Om Kamath, with team number 67.
Yeah, thank you so much.
Om Kamath, you may begin now, and you have just 5 minutes.
Okay, yeah. Just a minute.
Om Kamath is not here in the meeting, is it? I think he got disconnected. Dash, Om Kamath is in the waiting room. Can you please admit him? Okay.
Yeah, sorry for the delay. Just a minute.
You may begin. You have just 5 minutes.
Yeah. Is my screen visible?
Yes, it is.
Okay. Good afternoon, everyone. I am Om Kamath, and today I will be presenting a tool which I developed in order to find a secure way for spies to communicate. That is iSpy. So the online world is so easy to use that we often forget how fragile and dangerous it is. There are many problems which spies may face while communicating digitally. Some of the problems are lack of privacy, data leakage, and increased complexity, which can be intimidating at times. So iSpy uses cryptographic encryption for enhanced security. It establishes a peer-to-peer connection which increases privacy, along with the very simple execution which is compatible on most of the devices. Let me explain how iSpy works. The host will start the application and generate a token. This token should be shared with the person who wants to establish a connection. After entering the correct token, the connection will be established with the receiver. The messages which are sent are first cryptographically encrypted and can be decrypted only using the key which both end users have. Any person trying to intercept the communication will be unable to read any of the messages as the decryption takes place at the receiver's side only. iSpy is a simple tool which runs on the command line. It is built using Python. Socket is used to establish the connection between the nodes, and Fornet is a module from the cryptography package which is used for encryption of the messages. These are the screenshots of the tool working. So let me just give you the demo now. So first we'll start the host and peer application. After the host starts the application, the token is generated. First, the peer will have to enter the host name. After that, he'll have to enter the security key or the token.
And once the token is verified, the connection is established. Now both the spies can communicate with each other. And using the quit command, you can just close the connection.
Oh, your time is almost up. Can you please wrap it up quickly?
I'm done with it. So the additional features which can be implemented in the future is a GUI, which can appeal to the masses, self-destruct messages which would prove to be beneficial in case the spies get abducted, and the integration of ultra-wideband technology would help in faster communication when the spies are in close proximity without any fear of suspicion. This technology is currently being used by Apple in most of their products like iPhones and the newly launched AirTags. Yes, thank you.
What's your team number?
Team 67.
67.
Thank you, Om. If the judges have any questions, they may ask.
Just wanted to say very well done with the presentation. Good job.
Thank you, sir.
Thank you, Om. So you may leave now. Thank you for your time. Next up we have is a solo participant, John Soni. His team number is 7070.
Hello,
John,
am I audible?
Yes, you're audible. You have 5 minutes and you may start now.
Okay. Share screen. So what I have did is I just wrote this code. This is echo of, and then you declare the variable, and then you clear the screen, and then this echo messenger, which means if this messenger, it will be displayed on the screen, and after that you use the set as receiver IP address, which is n equal to user, and set m is equal to message, which is sender IP address, and then net send %n and m, and then we pause, which means the program has ended. And then to go to further into the loop, we use go to a, and and don't forget to save this file as bat file, through which we can directly use the CMD, through which we can communicate to the other device. And secondly, I tried to use with the C program. I tried it, but I didn't got it. After saving this, a screen like this will appear, in which you first apply you first put the IP address and then the message, and then enter. Then this message will be delivered to the other device. So that was it from my side. Thank you.
Thank you, John. That was a beautiful presentation. Judges, if you have any questions, please let us know.
What's the team number for John?
My team number is 70.
7070. So thank you, and you may leave now. So now moving on to the next one. The next participant is Paritosh Sabarat. His team number is 74. Paritosh, you may begin, and just know that you have 5 minutes from now on.
Yeah, okay. Thank you. Oh, can I screen?
Hello everyone, I am Paritosh Sabrat and I'm going to present my project, A Simple Calculator. I'm team number 74. Oh, just a second, sorry. Sorry for that. I'm going to present my project, A Simple Calculator. So my problem statement was to have to establish a medium of communication that prevents any suspicious. So my aim to achieve this was to keep it simple, keep it easy to use, and do it in a way that grabs the least attention. So how I achieved it? I used a basic calculator. This calculator will perform all the basic arithmetic operations which a simple calculator normally performs and so can be used for day-to-day calculations. So the secret in here is that this calculator has a secret hidden key. I have used the key hash to convert it into a communication device. So the communication. There's a code mode which can be activated using the secret key. When activated, all the alphabets correspond to their following number. For example, A is 1, B is 2, C is 3, and so on. So the advantage of this will be that it wouldn't seem so suspicious for a person to use a simple calculator. For a person outside just watching them, it will be just simply seem like they are using a calculator to do their maths functions. It's easy, and also it's easy to use, and also therefore it will be easy to communicate. The future developments for this calculator could be that a more encrypted communication between two such calculators can be made. Can also be used to type Morse code. It can be made more simpler to use, and also more secret modes can be added. This is the code output video, but I'll just show you the code right here. So I've used C++. This here, as you can see, I've used the switch case statement in which I've described all the different functions of the calculator, plus, minus, division, and multiplication. But here, when the secret key is used, I've made a character array in which all the characters from A to Z are stored. So I'll just run the code. Okay, so let's just enter two numbers 9 and 10, and I want to multiply them. It will give us give 90 as the answer. Let's rerun the code. But now we'll in the operation we'll put the secret key, that is hash. In this, the code mode is activated and each number denotes the corresponding letter. So to print high, 8 which is H, 9 which is I, and we have to press equal to print high is printed. Such that I can also print I can print
Since your time is almost up, I'd request you to please wrap it up quickly.
okay, so in this way I can use the corresponding numbers to print police or help in order to alert the partner or even the agencies. Thank you. That's it. Any questions?
Questions, right? Good one.
Okay, so we don't have any questions. Thank you so much for your time, Paritosh. And you may leave now. So the next up we have is Varun Nair, who's a solo participant. His team number is 98. Varun Nair, you have 5 minutes from now on, and you may begin.
Yeah, sure. Thank you. Just one second, let's share my screen. Like, are you all able to see the slide?
Yes, it's visible.
Yeah. So good afternoon, all. Today I'll be showing my solution to the given problem statement. The given problem statement was that the spies have been the given problem statement was the spies have been suspected of espionage and are kept in the safe house, and they wanted a safe and secure medium to communicate. Hence, my solution, Cypher chat. This tool allows the spies to communicate with each other securely by using a symmetric encryption algorithm. And when one spy sends a message to the other spy, the other spy can press the receive button to receive the latest message and also send the message at the same time. The messages that are sent can only be decrypted by those who have the key. Currently, I have assumed that both the spies have memorized the key, and hence only they know about it. The programs that I have used are Python, GitHub, and the cryptography module in Python. So, like, I'll begin with the demo now. Just one sec, I'll just share my screen. Yeah, so here, as soon as one, so then here, as soon as one spy sends a message like, now, then the other spy can press the receive button to receive this message right here, and then the second spy can also send a message saying that he has received the message. So, and then as soon as you press this message, the spy one also gets a message. Like the only limitation I found in this app is that I'm not like I'm not able to concurrently receive and send the messages as of now. So then, due to I'm not able to implement the socket programming, and then like for the future aspects, the UI and UX can be improved, as I said. The code can be used as socket programming to work on multiple devices on a network or on different networks. The program could be written more efficiently and can use a different GUI model other than tkinter to make it look better and more intuitive. And then any user will be able to send messages, and so hence we will add user authentication so that only the spies which have to communicate can send messages to each other. Yeah, that's it. Thank you.
Thank you, Varun, for finishing your time. Judges, if you have any questions.
Your team number is 91, right?
No, 98, sir.
98.
Just want to say good job on the UI. It looked catchy, let's say. So good stuff.
Thank you, sir. And thank you for all your time.
Okay, so we thank you so much, Varun, and you may leave now. Next up, we have is team number 20, and the team name is Idea 404. Abhinav, your other team members haven't joined yet.
They say they are in the waiting room.
Okay, let me confirm. Carby, can you please check once in the waiting room?
Yes, I'm checking.
What's the team number for Abhinav?
Team number 20.
Can you ask them to rejoin again? Because I can't see their names here.
Abhinav, I hope you have contacted your other team members.
Yes, they're trying to join. Just give me a minute.
Okay. Yeah, sure. Thank you. Abhinav, is it possible if you can start until your team members join?
They are saying they are in the waiting room. Could you please check?
Yes, sure. So we just joined. Okay, so you guys have 5 minutes and please wrap it up quickly. Thank you so much. You can start now. I hope I was clear before. Abhinav, Naitik and Veer.
Yeah, we can start. Veer, can you present?
Yeah, just a minute.
And just know that you have less than 5 minutes left to present, so just work accordingly.
Till Veer present, let me show you the code and it's working. Can you see my screen?
Yes, we can see the code.
Yeah, so We are creating an app which is basically a calculator, but when you enter a secret code, it will allow you to go into operation mode of encrypting and decrypting. And when you give the text and the key, the encrypted message will be directly sent to the email of the other spy. So let me show you the live, like I'm running it. It says, welcome to calculator, press enter to continue. Now the secret code we have given is Hail Spice. So when I give Hail Spice, it's asks me the operation mode. So I will encrypt. And now the message to encrypt is, I will put any message, hello, welcome to the world. And it will ask me for key for encryption. So basically we are using a module called crypto code. It encrypts based on the key. So it takes first convert all the message to hash it and converts the key to hash it and adds both the hash it codes. So I am giving the key welcome. Now, since there are two users, each user has their own passcode. So the passcode for user 1 is 1 and 2 is 2. So I will enter 1 and now the code will run. And once it's done, the code has automatically sent the email to the other file. Now I will show you my Gmail that it has automatically been sent. Can you see the Gmail Google screen?
We cannot see your screen.
This will share. Stop share.
Your time is already up, so can you please wrap it up quickly?
And so the message I sent is here. It is in encrypted format and the key is welcome. So now I will decrypt this with the same key. Control C. Share. So now the decrypted message has been sent back to the original spy message. If I am the spy, see, hello, welcome to the world. So we are basically enabling 3 layers. First, you have to enter the passcode, then encrypt, decrypt, and the
Nitish, you may stop now. We can ask the judges if they have any questions.
Okay.
No questions as such. Clear.
Okay, no questions. So thank you
Team
so
number
much.
20, correct?
Yeah.
Yes. Thank you so much for joining in. You may leave now, team. Next up we have is Collector's Edition, team number 12. And the Collector's Edition, you have 5 minutes and you may begin.
Is the screen?
Yes, it's visible.
Okay, so good morning, everyone. Yeah. So my friend Dev Palawat and I myself, Nikita Devda, are in Team 12 Collectors Edition. And so to begin with, the problem statement for the event is that we had to build a communication medium between two spies that prevent any communication suspicion. So the assumption that we made while making this is that the user has the access to the communication medium, and for the solution to the problem. So we know that these spies are being monitored continuously, so we cannot send across the keys for decryption of the text, and therefore we created a program that creates a strong decryption and encryption of the inputted text, which is unique every time. So also the two-factor authentication is used for further boosting the security. Now my friend, they will explain the working of the program.
Okay, yeah. So first of all, we take the input string from the user, then we check the string, and we actually, first of all, we flip the string into the reverse part, and then we generate a random character which will use a Caesar cipher to turn the string, to shift the string by random spaces. So for example, yeah, for that will happen first, and after that we will again reverse the string and add a random gibberish letters at the start of the string. So it is very hard to decipher. So I'll just show it. Yeah, so first of all, the two factors of authentication are as follows. Since this is used by spies and it is a government application, it will not be available to the public. Hence, the first factor of authentication is something you have, which is this application. And the second factor would be the passcode, which you would have to enter to get access to the application. Now, when we want, we have three options. So if you want to encrypt the data, I say, let's say hello world. So then we'll get the encrypted data. And if you want to decrypt it, we can just simply get some encrypted data, which we have. Wait just a second. Okay, I'll just decrypt this data. Just a second. So yeah, to decrypt the data, we can just input the string which we had before, like just a second. It's
Participants, please note you're left with just 1 more minute.
Yeah.
I request you to wrap it up.
So yeah, just to decrypt the data, we have to enter the encrypted string, which is as follows. Sorry. So yeah, we get the decrypted data back. So an advantage of this is that we do not have to share the keys, which could potentially leak the confidential data which we are sharing. So yeah, and for the code, we can in the future we could add certain features such as access for Morse code. We could also send a warning message to the government if someone is entering a wrong passcode, or else if someone is entering a encrypted data which does not give a regular output. So yeah, thank you. Do you have any questions?
All right, no questions. So thank you so much for your time, team, and you may leave now. Next up, we have is team number 42. That's Super Strikers. So team Super Strikers, you have 5 minutes from now on, and you may begin now.
Good afternoon, everyone. I am Pushkin Jain from Super Strikers. Today, I will be presenting you our project for hackathon. So, our project description: we have made a hidden app that looks as a calculator but opens a secret chatting string when the correct password is input. Else, it performs some mathematical operations according to the user. The assumptions we have made: both the spies know the password key and they share the messages by sending an image after renaming it as the message, so it does not look suspicious. Now I will ask my friend Ryan to explain the code.
Oh, Pushkin, can you please open the code on code blocks?
Is my screen visible of the code block?
No, no.
Yes, it's visible. The code is visible. Presentation.
No, code blocks.
Share your
Just a minute. Now?
Yes.
Yeah. So the code is basically like a Trojan horse. It's a calculator on the outside, but when we input the secret code, it then becomes the encryption decryption system. So here, can you run the code, Pushkin? Yeah. So is the code running? I can't see.
Yeah, it has written welcome to the calculator. Please enter the numbers you wish to perform the operations on.
Okay, so we can enter any two numbers, let's say 5 and 10. So when input 5 and 10.
Yeah, okay, 5 and 10.
So yeah.
Now,
So
please select the operation you wish to perform. 1 for addition,
Yes.
2 for subtraction.
So here we can put the secret code. We don't need to perform the
We
calculation.
cannot see the screen, by the way. Like, we cannot see this happening on the screen.
Yeah. Pushkin just looking. Yeah. Now we can see. So here we don't need to put 1 and 2 because it's just basic addition subtraction. We can put 42069. So please enter. So yeah. So now we can enter the secret message. So just enter Cypher or anything. Yeah. So now we have the choice. We can either encrypt the message or we can decipher. So this message we have to encrypt. So press 1. So now we have got our secret message. So this secret message, just copy paste. So here we have assumed that the message is sent through renaming a picture. So on WhatsApp, we can send a picture by renaming its name. So it's not suspicious. So then we are assuming that the second spy has received the picture and he knows the code now. So Pushkin, can you run this program again?
Yeah, Ryan, sorry to interrupt, but your time is almost up. Can you please wrap it up quickly?
Yeah, it will be finished. It will be finished soon. So yeah, so just input any number again, 5 and 10. So yeah, then put the serial code. So this is for the second spy, which is, so just copy paste the message that the second spy received. So now we are deciphering the code. So we will enter 2 over here. So the deciphered message, Cypher. So he just deleted a character by mistake here. So the message Cypher will be showed, but he by mistakenly did not copy a character. So that's fine. So this is the way the code works, and then the message is transferred. So the pros and cons of this are, the pros are that it's not very suspicious, it's not suspicious at all. The pros are that we are using SI code to
That's okay. Ryan, you can stop now. We'll ask if the judges have any questions and we can wrap it up.
okay. So do you have any question?
No questions, that's
Judge?
Your team number?
42.
Thanks.
Okay, thank you, Super Strikers. Now, thank you so much for your time and you may leave.
Thank you.
Moving on to the next one, Team Radicals. That's team number 35. Team Radicals, you have 5 minutes. Just make sure you finish it in 5 minutes itself, and you may begin now.
Okay, I hope everyone is here. Bindi, Lokesh.
Yes,
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 hi,
we
Parth.
can see them.
All right.
Yes.
Host, can you also admit my another device?
Sure, Kervi, can you please do that?
Yes, what have you named them? Like the
Uh,
device?
it would be starting from CC, if I'm not wrong, along with
Okay.
Parth.
Parth Maheshwari, yes, I admitted that.
Yeah. Thank you so much. Yes. Okay. So can we start?
Sure, you can start and you have just 5 minutes, so work accordingly. Thank you.
Sure. Sure. Thank you so much. Lokesh, you can go ahead.
Hello, jury. Good afternoon to you all. I am Lokesh Suryavanshi. My teammates Bindi and Parth from the School of Technology Management and Engineering (NMIMS). Today, we Team Radicals are here to present our VTV communication system. VTV is based on a two-way communication system that allows the sender to record a voice share and share it. This voice message will be converted to text and then will be encrypted for security purpose. The next process that occurs before the receiver receives the message is the decryption, and then the text is again converted to a voice, which is finally received by the receiver. In short, the sender's message goes through two-layer masking and therefore enhance security. I would like to call Bindi and Parth to explain the flow process. Over to you, Parth.
Okay. Thank you so much, Lokesh, for this wonderful introduction. Good afternoon, the jury members and all the viewers. So, as we all are aware about the time constraint, I won't stretch longer. So, as Lokesh said, we tried to make a VTV communication system where basically we can use voice, converting it to speech, and then again ciphering it in using the product cipher method, and then decrypting it and converting it again to the voice format, establishing a communication in that sense. And for this application, we have used Python as our core language and various other libraries. To put more light on the libraries and technical stuff, I would like to call Bindi to take up forward. Over to you, Bindi.
Yeah, thank you so much, Parth. Hello, everyone. I am here to talk about libraries that we used in our project. But along with this, I'd like to show you the output that I will give as a voice. And as Parth said, the conversion that it will make, the voice will be converted to the text and then text to voice. So you'll be able to see the screen where I will be inputting my voice and it will convert it to the text.
and the text will convert again to the voice, which you will be hearing in the form of system voice. So let me just run it and I'll show you how it goes. Yeah, so the libraries that we used in our project, that is basically the Python project, it is speech recognition, that is a library for performing the conversion of speech into text. And the PyTTSX3, that is text to speech conversion library in Python. Now we also used encryption and we also used Kinter. Kinter is the standard GUI library and it is used for the interface, which will solve problem and based on the object orientation. So this is what I said, and it will be converted into the text form.
Bindi, your time is almost up. I'd request you to please wrap it up quickly.
Okay. Jury members, as you can see on the screen, the text got recognized, but somehow I'm not sure we didn't get the audio output over here. But considering this, we also tried to, code the ciphering method. Bindi, if you could present that.
Sure.
Yeah. And as we had this time constraint of 24 hours in this hackathon, we couldn't link all the code files with each other, and we couldn't connect it with the MySQL database. But this is what we had to present from our side and our project. So, do you guys have any questions?
I'm not clear. Where is the encryption and decryption happening still? Like you converted speech to text and then what?
Yeah, so that's what I said. When the speech gets converted to text, what we thought is we will take it as an input and link it to the encryption decryption wala file, and then we'll run that file. Then that decryption encrypted format file will go to the user side, the second user side, where it will get decrypted. Then it will be taken as an input in text format, and then it will go up as an audio output. Okay.
So basically,
Go ahead.
so basically we separated all the files, but we didn't linked each other because of the time constraint. So, but we can do this easily, like within an hour, maybe.
So
What's your
right now
team number?
what you showed is like just voice to text. I did not see the main part of text being transferred, but okay, got it.
What's your
What's
team
your
number?
Can we just present the GUI part wherein we can take the text input and it will speak up?
There's a time constraint, so if the judges allow, only then.
What's the team number?
So the team number is 35.
25. Yeah. Okay, like let's do it quickly.
35. Okay. So here is the Kindle, and I'll just write down the text. Did you hear it?
No, Binti.
I didn't share the audio, I think. Um,
Hello, we are Team Radicals.
Okay, so this is what happened earlier also when we were trying to present the first file, and the text which got recognized, that also got converted into voice again.
yes, this one.
Okay, got it.
Okay, so jury members, this is what we had to present for today.
Good job. Interesting.
Thank you
Thank
so
you.
much, team.
Thank
Thank you for your time.
Thank you so
And
much.
Thank you so much.
yeah, you may
Thank you
leave
so much.
now. Now, coming up to the next team, that is Team Bingo, team number 8. Team Bingo, you have 5 minutes from now on, and you may begin.
Yes,
Just a second. Neha, you ready?
yes.
Yeah, okay. All right. So good evening, respected judges. I'm Ashweta Iyer from representing Team Bingo, and my teammate is Neha Grandi. We're Team 8. The tool we have chosen is a game algorithm to communicate for the spies to communicate with another. Our game is titled Riddles, and we've used C++ as a programming language and have used the online compilers to execute the same. These are the following assumptions we've taken into consideration. Since the two spies are under constant supervision and they're present in the same safe house, they cannot be caught messaging continuously on any device. Thus, our game algorithm allows them to send one message at a time using the game. In case the other spy wants to reply, he needs to log in again. For extra security measures, we've converted the inputted message into Morse code. Now I'd like to hand it over to Neha, who would show you on an online compiler how our game works.
First of all, I'll just brief you about the cases. So the case one, Spice plays the game. So here's how the game works. The initial display is given as input name, age, game ID, and the spies have to input a 8-digit code only known to them, which will allow them to input one message only. In this case, I have chosen a random code that is 74538108019. So for the case 2, the non-spies plays the game. For the other players of game, only a 6-digit code can be input, which will lead them to the game. For the non-spies, they can input a 6-digit code, game ID. For any 6-digit code, they will be declared to a game titled Riddles, where the players will be given three chances. They will be given the choices to choose the number of rounds, like 1, 2, or 3. Then the end display for them would be the total points scored after they finish the game. So here in the part 1, we have tried to write a random 6-digit, as you can see here. So the results are displayed below, outcomes, whatever what it is. And we have tried two more trials with round 2 and round 3 by inputting different values for name, age, and game ID respectively from the program outputs. We have concluded that no one has access to the secret channel other than the spies. So I'll just show you the demo of our code. So this is the case 1. Like I'll input name, age, this is the spy ID which we know, and we'll enter a message which will be converted into a Morse code, and the message will be sent to the other spy. Now the other scenario or other case is like this is for the non-spy. Age and the ID, random ID, 6-digit ID. And now they need to choose the rounds they want to play.
I'm sorry to interrupt, but your time is up. Can you please wrap it up quickly?
Yes, sure. Just a second. And so this would end up like this. So yes, thank you for listening.
Thank you so much, Team Bingo. If the judges have any questions, they may ask.
Just quick question. So the similar way how encryption worked, decryption also works the same way. I'm assuming, right?
Yes, sir.
Okay. Okay.
Thank you, sir.
What's the team number?
Team number
sir.
Team number 8. Thank you so much, Team Bingo. You may leave now. And I'd like to pass on this host to Nagisri, which will take over from here.
Thank you so much, Tanishka. Taking it ahead from here, we have a next team, which is called Runtime Errors. We have Devashri, Devendra, and Rudra, and the team number is 38. That is 38.
May I share the screen?
Yes, please. You will have 5 minutes for this presentation. You may begin now. Thank you.
Okay, so I'll start. A very good afternoon to everyone present here. We are team 38 Runtime Error. The participants of the Cypher competition are Rudra, Devashri, and Devendra. Now Rudra will be taking about network setup in detail.
Okay, so talking about networking, we have a server file and a client file in these situations. For our situation, the server will be the sender and the client will be the receiver. We are using socket library from Python here. The socket is a method to declare a socket object. Here, bind declares a server and listen looks for clients. Similarly, accept establishes a connection and connect looks out for servers. Our client is the receiver and it uses recv method of socket join to accept data. Next, Devendra. It also uses a fixed host name and a port taken input for, like in this presentation, while the YouTube video also shows using a set value in the code. Now, Devendra will take up to explain the encryption we are using.
Thank you, Rudra. So, in our system, we encrypt data using a very primitive form. We have a variable named code in which the encrypted string will be stored. Here, the range of I is from 0 to L, where L is the number of total characters in the string. In this, the assigned value of I is divided by 2 to check if the number is even or odd. If the remainder is 0, then the character is even and it is pushed 5 alphabets backward and stored in K. If the remainder is 1, then it is pushed 5 alphabets forward. And every time the new value of K is added to the string till it reaches to L. And by this, the encrypted string is formed. Here, in the client output, we have to provide host address, and then the connection between these two devices is possible. Now, Devashri will tell us about the encrypted message from the server to the client.
Thank you, Devendra. Now we will see how the encrypt message is sent by the server to the client. By clicking enter, and if the connection is very strong, the message goes to the server, but it is not shown on the IDLE. Now we will see the reason why the message does not show on IDLE. For an added layer of privacy, the data is stored in a file located somewhere on the device. The authorized personnel only can look into the file for all the details, while the unauthorized ones have to look through the whole device. We are very grateful for this opportunity to participate in, and Cyber Ciphers has piqued our interest in coding language. Thank you, everyone.
Thank you so much for that presentation. Judges, if you have any questions. All right. Thank you so much, team. You can leave now. Next up, we have the team name Programmers. The team number is 9, and they will be joining in right away. Team 9, you may begin your presentation by sharing your screen, and you will have 5 minutes on the clock. Thank you. By sharing your screen, and you will have 5 minutes on the clock.
Can you see my screen?
By sharing your screen, and you will have 5 minutes on the clock.
Can you see my screen?
By sharing your screen, and you will have 5 minutes on the clock.
Can you see my screen?
By sharing your screen, and you will have 5 minutes on the clock.
Can you see my screen?
And you will have 5 minutes on the clock.
Can you see?
I'm sorry about that disturbance. Team, could you please reshare your screen? Sorry about that disturbance.
It's happening again.
Reshare your screen. Sorry about that disturbance.
It's happening again.
Reshare your screen. Can I ask someone else to share your screen? For someone else from your team?
Hello. Hello. Hello.
Yes, this is better. Can you please try sharing your screen once again?
Hello.
Yes, this is better. Can you please try sharing your screen once again?
Can you please allow Anushka to share the screen? Anushka.
Can you
and any team member of mine. Anushka to share the screen. Anushka. And any team member of mine.
Team 9, is someone else sharing from your screen? Could you please maybe, all right. Yes, we can see your screen now. Can you please try unmuting yourself?
Yeah, is my voice echoing?
No, it's not echoing. Please continue. You'll have 5 minutes on the clock exact. Thank you.
Okay. So good afternoon, you all. We are team number 9 programmers, and I am Yashi Jain, and my other team members are Utkarsh Kakaria and Anushka Jain. As we know that we needed to create a tool with which individuals can communicate with one another in a secure fashion and a secretive manner. So here I will give you all a brief description of our project. We have knowingly built this program that no one expects this. This is not a chat box or a server, but this is something as simple as possible. So here it comes. It goes like we have created a medium through which they can only share important
Is it
messages
not
with
echoing?
each
Is it
other.
not echoing?
Which they can only share important
Is it
messages
not
with
echoing?
each
Is it
other.
not echoing?
Which they can only share. Yeah, it's echoing again.
Is it possible for you to continue for the rest of the presentation?
Yeah, we will. Okay, so as you said, it had to be a government spy or something, or some conversation which is not known by the people. So we came up with an idea that these two spies are having normal conversation and people don't know that they are spies or something, but they know what they have to do with the text they are sharing with each other. So the two spies wanted to meet each other and want to talk in such a way that no one else get a sniff about what they are talking or what they are having, what the conversation they are having. So we have coded it in such a way that only the first word after every question mark will be shown up. So the person will get his message, what the other person wants to convey, without anyone knowing what is happening between them. So here it comes. Something which is not a server, something which is not a chat box can never be hacked, right? So that's how we do it. And the steps involved in this process are first input, then a message in the form of text. Then we have done encryption. Then again, the message will come in the form of text and then decryption. Then we assume that they know the code language and then it will print. So further, Utkarsh will be continuing.
Okay, so as we know, we wanted to text something and in a form of message. So we use string and we stored in a form of temporary variable that. Then again we encrypted and decrypted in a very simpler manner. Like we used casting. Can you go ahead? We use casting. Same method for encryption and decryption both. So again, the main part comes here. This can be altered every single time you want. Here we used question mark for this process. So every word after the question mark, can you go ahead? Yeah. So every word after the question mark is the word they have to put, is the word which is being used to convey the message. Should I, can you go to the example?
So when I run the code, like, hey, how are you? So every word after the question mark, it's programmed in such a manner that every word after the question mark is taken. So after hey, there is how. After been, there is while. So how will we meet today? So like this, any message can be conveyed.
So now that we've seen the code, let's try explaining it with an example. So as Utkarsh explained, this is the example. The spy wants to print the final message, which is highlighted here. How will we meet today? And for that, he types the message, which is above that, the long as para. So let's see how that is executed in the next slide. So the first output that he gets is enter your message, and he gets the warning that when he has to end the string, he has to use /end. So he types this message that was shown on the previous slide, and then he presses /end so that the string is entered, and now there's the time for the output. So
Sorry to interrupt.
as you can,
5 minutes are up. Please wrap it up quickly.
yeah, this is the last slide. So as you can see, the encryption is done on the basis that every word, every letter has been replaced with the letter, 2 letters after the letter. Like for A, it has been shifted to C. For C, it has been shifted to E, like that. So the
I
encryption is
forgot
done,
to
and
mention
then
here we used casting plus 2 letters that can be changed. I knowingly use this casting because every encryptions and every decryptions can be hacked using today's method. So this is not something which is assumed by people. Yeah,
so the
continue.
encrypted part is again decrypted, and then the final message, which is the considering the word after the question, after every question mark, is how will we meet today. So that is how the spies will convey in their code language, which is not so obvious to other people. That's it. Thank you.
Thank you so much, team, for that beautiful presentation. Judges, if you have any questions, I will request you to ask them now. Considering none, team, you can leave right now.
Thank you. Thank you so much.
Thank you so much. For the next team, we have Vitrag, Malav, and Vedant Melkari, who are team number 55, and they'll be joining in right away. Seeing the participants have arrived, I would like to request them to share the screen and begin the presentation, and they have 5 minutes on the clock.
Hello.
Vitrag,
Am I
could you
audible?
please share the screen?
Yeah, just a sec.
Hi, judges. I am Malav Mehta, and we.
Yeah, just a sec.
So
Yeah.
here are my teammates Vitrag Khatadia and Vedant Melkari. So our problem statement is that we have to establish a safe and secure mode of communication to between two clients, that is Spy1 and Spy2. We first thought of creating an Android app, but then we wanted to keep things as simple as possible and point to point. We did not want to make it much complex. So we thought of using a familiar concept, that is socket. So what socket does is it basically establishes a connection between client and the server. It also helps you to establish that connection within the same device and between two devices, but under the same server. So we first implemented the program in using Java. Vitra, could you please show the output? The Word document. Yeah, so over here, as you can see, we first established the connection between the server and the client. When the server connects to the client, it shows a message to the client showing that connection established with the server, and the same message goes to the server showing that connection established with the client. And so from here, the server and the client can talk to each other. They can chat with each other. So over here, as you can see, the client first sent a message saying hello spy1, and then the server responded saying hello spy2. Basically, it easily helps you to talk to each other in a secured manner. So if you want to end the connection between the client and server, you simply have to type in end and it will destruct the connection between client and server. We wanted to add encryption and decryption to the program, but due to some difficulties, we could not do it. And so to make it more appealing, we went ahead and added GUI to the code. Vitra, could you please show?
Yeah, so from here I will continue. So as you can see, this is my GUI. This is my application window for server one, also known as spy one. So this is some of the text area, whether he or she needs to write in the message, and this is the send button. And this black window is the display where the incoming message from spy two will be displayed. Similarly, on the other hand, I have a similar looking application window for spy two as well. So let's just do a quick dry run, and I'll just show you how this thing works.
So as you can see over here, spy1 is our client and spy2 is our server.
I hope my screen is visible.
Yes.
Let's say spy1 is our third teammate Vedant Melkari and spy2 is Malav. So let's just do a quick dry run.
Yeah. So supposing I choose to type what's the update.
So I respond to that.
Sorry.
Continue.
Yeah.
So to that I respond that the plan is on. The plan is on. Vitra.
Yeah.
So after receiving this one, if I say okay, copy.
So over here, if I plan to end the communication between me and the server, that is the spy one, I just have to type in exit.
As you can see,
it will end the communication.
As soon as Malav just sent exit, the server window as well as known as spy one, that window will get crashed. It will get disrupted. So the chat is deleted. Back to the presentation. So this is one of the output which you have considered. Yeah.
We further plan to make a web app or an Android app, and we also plan to add encryption and decryption key to the program. Thank you. That's it. Any questions?
Thank you so much, team. That was a really well-made presentation. Judges, if you have any questions, would you like to ask them? Seeing none, I would like to thank the team, and you may leave now.
Thank you.
Thank you.
For the next team, we have Team Resistance, who have Hardik, Jeet, and Sharvari in them, and they'll be joining right away. The team number is 37, that is 37. The team members have joined in right now. I would like to request the team to begin the presentation by sharing the screen and to note that there are 5 minutes on the clock for them.
Yeah, hi there. Yeah.
You may begin now.
I'll share the screen. Yeah. Yeah, is the screen visible?
Yes, your screen is visible. Please continue.
Yeah, okay. So we'll start the presentation. Good evening, everybody.
Yeah. So good evening, one and all present here. Our team name is Resistance, and the team consists of me, Sharvari Sheth, Jeet Shah, and Hardik Thakur. So the topic that was given to us was considering these two spies are suspected of espionage with their safe house under constant supervision, and we have to make and establish a medium of communication. So the introduction to our project name is same as our team name, that is Resistance. which also ironically means that we are resisting the communication from being infiltrated. So I'm sorry, can you hear my voice?
Yes, we can hear your voice. Please
Yeah,
continue.
okay, sorry. Yeah. So this project is two-way end-to-end encrypted chatting platform. We have secured this communication by putting two layers, that's namely message encoding and message encryption. I'm going to point out both of these points with the code. So the message encryption we have done by using crypto.js, by using the crypto.js IV and IV and the key. Yeah, and for the encoding part, we have used the predefined functions that is B2A and A to B. B2A is used for encoding and A to B is used for decoding. Yeah, so now coming back to the PPT. I'm going to show one example. So if I just take a sample input here, the sample input is going to be encrypted. And as you can see, this is the encrypted string. And then the encrypted string is going to be further encoded. And here is the encoded string. So now this process is going to be demonstrated and explained in detail by G.
Yeah. So hi, this is Jeet here. So yeah, I'll explain a bit about our application, and also I'll explain a very small piece of code and run a live demo. So this is a snapshot of our chat. So here, as you can see, this is a sample conversation happening between the two spies, where the first spy says hey and the second one says hi there. So this is just the window of the first spy. The same would be there in the side of the second spy too. So this is the basic structure of our chat, and in the backend we have this. That is, this is just for debugging purposes that we are showing you here. That in the console on the client side, here you can see the encrypted message. That is the first layer of security, and in the server side, that is in the terminal, we have a console logged. Here you can see it is the two-layered encrypted message. So here our aim is that to the server only the two-layered encrypted message goes. That is encrypted and the encoding. So encryption is done via crypto and encoding via the functions told by Sharvari. So I'll just give a short run on the code. So I have kept two local hosts running in behind. So I'm just running the server now. So here, as you can see, it just ran. Now I will go back here. I'll reload the page. Yeah. So here in VS Code, as you can see, it is spy connected. So there are two spies connected right now, currently. So yeah, just a second. Yeah. So here I'll write a message, say for Jeet example. And so here it is displayed on both the sides. And Sharvari here, I'll write, so it is displayed on both the sides. So just a short overview. Here in the console, you can see the message encrypted first layer. This is for Jeet. And for here on the second spy window, it is again the same message encrypted, Sharvari.
Can you please wrap it up quickly?
Yeah. Just a second. So this was the first layer encryption, and here you can see the server side as the two-layer encrypted message. So yeah, now moving on to the presentation. Now Hardik will carry forward. Yeah.
I'm very sorry to interrupt, but you will have to wrap it up quickly because your time is already up.
Yeah. Just 1 minute more. We'll just finish it off.
Okay, so these are the technologies we have used in our project, and moving forward to the tools which we have used in our project is mostly PyCharm and VS Code. Concluding the project, we tried our best to establish a secure mode of communication for the spies to communicate with each other, and in future we would try to implement file transfer and voice chat, and for in the same project that we have currently now. So, thank you.
Thank you so much for the presentation. That was really well explained. Judges, do you have any questions for this team?
What
Seeing
was
none.
team number?
Yeah, the
Team
team number
number.
is 37.
37.
Okay, thanks.
Thank you.
Thank you so much, team. You may leave the room now.
Thank you.
For the next team, we have Himanshi Joshi and Rashmi Prabhu, which are team number 49, that is 49. They'll be joining in shortly. I can see the team members have joined now. Team members, please feel free to begin now, and you have 5 minutes on the clock. You can share your screen.
Hello.
Yes, we can hear you.
Okay, sorry, just 1 second. Yeah, can you see the PPT?
Yes, we can see the PPT.
Okay, so hello everyone. I'm Rashmi and my partner is Himanshi. Together we're Team Benti. I'll start off with a small animation on a problem statement that was given to us so you can kind of understand what our mindset was towards this problem. Now, basically, we have two spies who wish to communicate with each other. However, they are under constant surveillance. Now, we are tasked to establish a secure means of communication between the two spies without raising any suspicion. Since the data was supposed to be kept confidential, we have decided on taking inspiration from the RSA algorithm. The algorithm says that the mediums who wish to communicate between each other should have a public key and a private key. We won't go into details on what those terms inside the bracket means yet, but all you have to know for now is that private keys are only visible to the respective spy and the public key is visible to both the spies. This algorithm makes sense because only these two spies would be having the keys to access the data. There are also some terms related to the RSA algorithm, which would be explained by Himanshi now that we'll see the code.
So we'll start with the code breakdown. We have chosen two prime numbers for our code. We'll use the prime numbers because the security of many encryption algorithms are based on the fact that it is very fast to multiply two large prime numbers and get the result. While to do the reverse, it can be extremely computer intensive. So the first function we have is get position, which generates a secret message based on the position of all the letters of the input message using the index of each letter in the English alphabet. Indexing starts with 0 for letter A. So, for example, for the input message hello, a secret message 7 4 11 11 14 will be generated.
The secret message list then gets passed down to the encrypt function. We first start by checking if both the numbers are prime or not. If yes, then we get to the value of e in e comma n. For this, we call the public key function. Now, on your right side, you can see the public key function. FUNC is the phi function which we calculated before. For the for loop, we make sure the value ranges from 2 to a number lesser than phi function. While traversing these numbers, if we come across such a number that gives the GCD value between the number itself and phi function as equal to 1, that particular number gets saved in variable e and then it gets returned to our encryption function. Now, back in the encryption function, we have defined encrypted cipher list called ncipher underscore n. We run another loop on the secret message. The purpose for this loop is to create an integer value. How it does that is that it takes the value from index 0 from the secret message and then it raises e to it. Now the whole of it gets modded to value n. Whatever integer value gets returned, we add that to the encrypted cipher list and it repeats until the secret message list is out of elements.
Next, we have the code book. A code book is like a book that both the spies have, which contains fixed words for each position of the cipher code generated. The cipher codes just need to be mapped to the index in code book to get a cipher text. This cipher text looks like a grocery list to people, and hence it is not suspicious. Next, we have decryption. The cipher code is generated by mapping the cipher text items to the codebook index. A private key is generated, which is passed to the decrypt function. In the decrypt function, each cipher code is converted to a secret message code by raising the value of the cipher code to the power of private key and then computing its mod with n, which is the product of the two prime numbers. The secret message is then converted back to plain text by mapping the values to the letters in the English alphabet.
Then we have just pasted the full code in sequence that we had written. And that's the end.
Thank you, Rashmi and Himanshi, for that wonderful presentation. Judges,
Thank you
if
so
you
much.
have any questions?
Thank you.
Seeing none, thank you so much, team. You can leave the room now.
Okay. Do we have to show a demonstration of the code, like live demonstration?
That was a part of the presentation timing, to be honest. But
Okay.
timing is not matching up right now. So
Okay. Thank you so much.
Thank you.
thank you so much. Next up, we have Pranaya, whose team number is 2323.
Yes, thank you. I would like to share my screen.
Yes, you may please share your screen. And you will have 5 minutes on the clock. Please do not exceed the timing.
Yes, okay. Can you all hear me?
Yes, we can see and hear you clearly. Thank you.
Yes, okay. So I'm Pranay from Team 23, and my project is Secure Line X. So this is the problem statement which was given to me, and my approach was pretty simple and straight. That to create a secured line network to connect multiple clients, basically spies in our channel to a secured server, and then further they can communicate with each other in a common chat room. Then this is the flow of the project where there's a server and the client. The socket is basically used to bind as in connect the server and client to each other, and then this is how it will work. Like it will bind for the connection and then listen for the connections and then finally accept it. Whatever communication will happen between the server and the client will be like the data will be encoded in bytes, and then further the transmission will be carried forward. And now these are the libraries which I have used: socket, select, and arino. Then further, this is the implementation. So now basically the server is up and running and it is searching for responses. And now the client, basically our spy one, is now online, and it has to enter the specific IP address of the server, else it won't be able to connect. And then the spy has to enter its unique name. So in our case, it's alpha. And then here the agent will be able to communicate. So if I write any message over here, it will be received at the server, and the server will be able to read it. Then next, here is the client, basically our other spy. So it has to enter the unique IP address and its name. And whatever it will send, it will be reflected on the server as well. Now, if I write another message over here, and I can see that beta has already written a message, and over here, if I again enter, I can see that alpha has replied to it. So in this way, the two spies can communicate with each other. And yes, that's pretty much it.
Thank you so much for your presentation. Judges, do you have any questions? Seeing none, thank you so much for your presentation. You may leave the room now.
Thank you.
Next up, we have Yash, Kevin, Dash representing Team Neural Theft, and the team number is 27, that is 27.
Hello.
Hello, participants. You may begin to share your screen. Yes. And you will have 5 minutes on the clock. Please do not exceed the timing.
Yes, of course. So just 1 second. So hello, this is Yash Shah, and we are Team Neural Theft. Along with me, I have
Kevin Garia. I'm Kevin Garia. Next slide. So basically, for the problem, the solution that we have thought of is that we create a file encoder and a simultaneously decoder, which through which we can use steganography and a web-based instant messaging platform to transfer files from one agent to the other or vice versa. So basically, we'll send an image with an encrypted message inside it. We'll send it to the other agent, and then that other agent will have the same software through which he will decode it and he'll get the message. So let's move ahead to find out how it is done. So first of all, the technologies used in this project are Node.js. So Node.js was created to make the messaging app. So like agent 1 wanted to send the image to agent 2. So how would he do that? He would send it through a chat app which we created on Node.js. Then we had Python. We use Python mainly for making the encoder and decoder. So in order to encrypt a message inside the image, we use Python. We also use HTML, CSS to make the chat beautiful and so that it looks good and it can be used easily. That will continue now for the other technologies.
So after what Kevin said, we thought let's use, so what library is there? What is the best library that we can use to import images into Python code? So we went with PIL, which is Pillow now because PIL is discontinued. So using PIL along with Tkinter, which is a GUI framework for Python. So you'll see ahead that we've used, so the entire encoder and decoder are fit into a GUI that use the Tkinter framework, and Stegano. Stegano is just a steganography module that we've used. Next. So you might wonder what is steganography and what is LSB. So let me first talk about steganography. Steganography works by hiding information in a way that doesn't arouse suspicion. And one of its most popular methods is the LSB method of steganography, which stands for least significant bit. So the LSB steganography is an image steganography technique in which messages are hidden inside an image by replacing each pixel's least significant bit with the bits of the message that is to be hidden. So now you think it sounds really interesting. Well, we did it. So next, Yash. So there are two phases of this project. One is the entire steganography module that we've used in a Python program, and one is the instant messaging service that we've used. Next.
So to start off with the steganography aspect, we use Python for that. And here is the program working. So let me just, so here you can select any, you can encode any file you want. So you select a file here. You take this image, let's say, you open it and you create a message. So let's say there is some hidden text you want to send. So you send hidden text here and you encode this. So it's ask you if you want to encode confirmation and you say yes. So this will be then in your file section will be saved as the image underscore encoded JPG. After that image is there, you can use our Node.js server to send the image from one person to another. So this is a chat me and Darsh have going on. I have already sent him the image because sometimes images take long to send. You can see that this is dynamic and working perfectly. So if I send a message here, it will be received here at the same time. So I can go here, I can save this image and I can save it as test.jpg in my downloads file, and I can just select all files here and I can just save this. If I go back here and click on decode here, select a file and use this test.jpg and decode this, here you see the text message that was hidden in. So that's about it.
Thank you for that really insightful presentation. Judges, do you have any questions? Seeing none, thank you so much, Team Neural Theft. You may leave the room now. Next up, we have Anish and Tarun from Team Beans, and their team number is 6.
अबे इतना बढ़िया प्रोजेक्ट बनाया था भाई ये लोग ने.
Shresh, I think you're unmuted. Could you please mute yourself? Continuing on, we have the next participants, Anish and Tarun in the room. You can share your screen. And you will have 5 minutes on the clock. Please make note of the timing and do not exceed it.
Yeah. This is our presentation.
Yeah, so we are team 6 made up of Anish Nair and me, Tarun Mahajan. You're going to be presenting our code. So our spies use a predefined key to encrypt and decrypt the messages being sent. We encrypt these messages on the code that will be running on the device that they have.
Entering a key ensures that the message cannot be deciphered by anybody without the key. The spies enter the message they want to encrypt. We get the index value of an alphabet and add our key to the index value. Then the alphabet associated with the new index value replaces the original alphabet. The encrypted message will now be printed. Thank you. I'll now run the code for you. Now we have to enter the key over here. Let's say our key is 123 and our message is meet me outside the building. It's going to be encrypted and then decrypted again, as you can see over here. Thank you. That will be all.
Thank you so much, Team Beans, for your presentation. Judges, do you have any questions for them? Seeing none, I would request the team to leave the room now. Thank you.
Thank you.
Next up, we have Tangish Sanjay, and he will be a solo participant. Also to mention, his team number is 59, and I can see that he has joined the room now. Tangish Sanjay, you can begin your screen sharing, and you will have 5 minutes on the clock. So please make note of the timing.
Okay. Thank you, judges. Good evening, judges. So my topic is this coding one only. So now I have given my topic name as Caesar Cypher. It's the most basic one and the first one made in the world. So I will start with it now. So what exactly is this Caesar Cypher? It was used by Julius Caesar to send messages to his general. So it's nothing but the shift of letters by a specific non-changing number. So here's the problem statement. There are two spies. They are suspect of espionage with their safe house under constant supervision. So we have to establish a medium of communication that prevents any suspicion and may or may not work on the same device. So I went with the most basic one because when people try to like uncode these stuff, they try to think of many hard work. So we could just go very simple approach, that is the Caesar Cypher. So here I have given two programs to both the spies. So with the one code, they could cipher the code and the other one deciphers the code. And while this ciphering is happening, and I'll make sure that not only one shift is there. There can be, they can change the number of shift that happens. And when sending a number, they could use the alphabets or the symbols over here while sending a number. I'll just show it to you now, the code. So here, this one is the Cypher one. So here it's written hello everyone. So when I run it, the code comes over here as down like this, the Cypher version, and I could change the letters for the shift. So the first spy sends like this. So I could just copy it, and in the second one over it's already there. So the shift is 7 again. So this is a decipher one. So when I run this again, you get the code as hello everyone over there. You could just go here and change the shift. Suppose you are saying that 7 is not right, and you could go with a 5. So you run the program. So it gives a different code, different Cypher code. So you can again just copy it and go over here and just change this over here. This way, when you run it, it will give you a wrong one because the shift over here is not changed to a 5. So now when you run it, you will get this hello everyone. So this is the most simple one, so they could not get too overcomplicated things. That's all, judges. If you have any doubts, you can ask.
Thank you for your presentation. Judges, if you have any questions. Seeing none, thank you so much for your presentation. You may leave the room now.
Thank you, judges.
For the next team, we have Rishabh Zaveri. He's a solo participant, and his Team number is 104. 104. He will be joining us shortly. The participant is here. Rishabh, feel free to share your screen and begin the presentation. You will have 5 minutes on the clock, so please take note of the timing.
Okay, thank you. So can you just confirm if you can see my screen?
Yes, we can see your screen.
Okay, so the solution I have come up for the problem of the hackathon is secure com, or that's what I am calling it. So I'll just start with the live demo of my app. I have already created a few accounts to not waste any time right now. So I'll just log into the accounts. And notice that right now all the other users are offline, but as soon as I log into the Spy2 account, you'll notice that Spy2 comes online over here. And the idea is that I've just made an app you can see the URLs. So one URL is on the local host, while the other URL is on another domain on my network. And the problem statement mentioned that the two devices must two different devices must communicate with each other. So to demonstrate that I have hosted this on another domain on my own network. Now I have not been able to complete the entire UI of my application, but the message service, I'm sorry. Yeah, so both the spies can communicate with each other, but right now the message UI is not complete. So I'll just use the browser's console to demonstrate that messages are indeed being received by both the parties. Yeah, so as soon as one spy messages another spy, you can see the, so so you can see that the other spy received this message, and just to show that it's the same message, like I have reached the base, and now this spy can reply to this spy, one can reply to spy 2. And just to prove that spy 2 has also received the message, I can show that the grade B questions. So this was my app. Like two clients can communicate with each other. And as far as the security is concerned, I have restricted this domain to only signed in users, and I can demonstrate that also. So once I log out, and if I try to access the home endpoint, which is for the chat, it's restricted, and it will always redirect you continuously to the login page. So, and now I'll continue with my presentation. So the technologies I've used to build this app are Firebase, React, and Tailwind. So I've used Firebase Auth for authentication. I've used Firestore, which acts as a real-time message transfer service as well as a database for the messages. I've used React for the front-end logic and Tailwind to style my app. The future prospects I see in this app are that I will like to add end-to-end encryption using HMAX SHA-256, but I found the time 24 hours to be quite less for me, so I couldn't implement a lot of these features, but I'm sure that I'll implement it soon. So another thing is that I will host the website on an actual server and not just on my local network to actually enable multiple devices to use the service. I'll ensure that I'm also thinking of adding a feature where messages will expire after a certain interval of time, and the UI completions and improvements are another thing I'm looking at in the future. And that's it.
Thank you so much for that interactive presentation, Rishabh. Judges, do you have any questions for him? Seeing none, I would like to request you to leave the room now. Last but not the least, we now have Team Supernova with members Arish, Rajveer, and Tanishka Chaturvedi. Their team number is 43, but that is 4-3. Team members, you may begin to share your screen, and please take note of the timing, which is going to be 5 minutes on the clock. Thank you.
Should I start sharing
Yes,
my
Rajveer.
screen?
Yes.
Yeah,
yes.
okay, thank you. Can you see my screen?
Yes.
Screen is visible.
Okay, yeah. So just a second. Yeah, so first of all, thanks to all the judges for sitting throughout the day for us. And without wasting any more further time, let's begin. So this is team number 43, Team Supernova, which consists of Arish, Tanishka, and Rajveer, which is me. So let's begin. So next slide, please. Yeah, so the problem statement. So as you have listened to it 1,000 of times, at least by now. So the problem statement we were given was that we had to consider two spies. We are considering James Bond and Felix Leiter from the and Fleming's James Bond. So they are suspected of espionage and they are kept in a safe house under constant supervision. We are making assumptions that they are using only one device, which was created by Q Quartermaster, to communicate to each other. That is Felix and James Bond at the one at a time. So they are presented with three options at a time. They have to, there's double protection, the password, and the key. And they are given with three options to check the inbox and to leave a message or to just end the whole session. So moving on to the next slide. We have used DES, which is Data Encryption Standard, as a tool for our program. It is an algorithm, it is a block cipher algorithm that takes plain text in blocks of 64 bits and converts them to ciphertext or cryptic text using keys of 48 bits. It is a symmetric key algorithm, which means that the same key is used for encrypting as well as decrypting the data. So passing over to Tanishka.
Thank you, Rajveer. So, coming to the implementation, first is generating keys, second, encrypting the plain text to ciphertext, and third is decrypting the ciphertext to obtain the plain text. Next slide, please. So here I've made written a flow chart of how to explain data in encrypted standard algorithm. First, the plain text is taken as an input, which is of 64 bits. Then the initial permutation happens, and after that, that permutation goes through 16 rounds of compression permutation operation, within which the compression happens, wherein every every eighth bit of that 64 bit is ignored, which is the compression, and this happens for 16 rounds, after which it is divided into two parts, left plain text and right plain text, both out of 32 bits. And then they're swapped. And after that, we are left with a left and a right column. So here a right column is a more favorite one. So where there we perform the expansion permutation, wherein the 32 bits is made into 48 bits, and it again goes through this XOR operation. After which it goes through the substitution box, which is continued for 8 times. and in the substitution box, 6 bits are inserted and 4 bits come out of it. So giving us 4 rows and 16 columns this column. So, and after that calculation, we are left with the ciphertext. Next slide, please. So using that same 64-bit plaintext and using the DES algorithm, we can change it to ciphertext, and the same can be reversed and applied to change ciphertext to the plaintext. Now, next slide, please. And I'd like to pass it over to Arish.
Thank you so much, Tanishka. Here is the flow of a program. First, the password is asked to the spy. After entering the correct password, the spy are displayed 3 options, and if the password is wrong, then a program will self-destruct itself. So there are 3 options: leave a message, check the inbox, and end the session. If the spy selects the second option, then there are no messages, and there are no messages by the other spy. It will display that there are no messages. Next slide. If the spy selects option 1, they have to leave a message and also required to enter a key. If the spy selects option 2 and there is any message left by the other spy, it will display the message in ciphertext as well as a plain English. If the spy selects option 3, the program will end itself. And we have, after each, a program also has a security key which has to be entered after entering the message so that no one else can access it. And it adds to a new layer of security. So now let's have a look at our example, our output. So after entering the correct password, so this is a conversation that is going on between the 2 spies. First, the first spy clicks the option 2. So since he is initiating the conversation, so there are no messages right now. Then he enters hello after clicking 1 to leave a message, and then he enters the key. So when he enters the key, this adds up to the second layer for security. Look, first he's entering the password, then he's entering the key. So there's a 2-layer of protection. After that, his message is recorded, and then the second spy takes it over, and then he again has to enter the password to access it. And the ciphertext which is converted, it is again decrypted to a normal plain English, and then he can access it. And this conversation goes on until any one of the user clicks 3 and the session ends. So I'll hand it over to Tanishka and she'll end the
I'd
presentation.
just like
Thank
to
you.
highlight on the fact that we discovered, understood, and learned how to implement the DES concept in a span of 24 hours, and also the fact we got presented in front of such a prestigious panel of judges. So that's victory for us. And if you have any questions, please let us know.
Thank you so much for that insightful presentation. Judges, do you have any questions for them?
Good job.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Thank you so
everyone.
much.
Seeing no more questions, I would like to request the team to leave the room now. Since we have concluded all the presentations, I would like to thank the jury from my entire heart. Your patience throughout the duration has been inspiring and really reassuring, and we extend our sincerest gratitude to you for the same. We look forward to a chance at collaborating with you again in the near future, and we really hope that this experience has been just as enriching for you as it was for both the organizing committee as well as the participants.
Thank you.
Thank you. It was a really good
Nice.
experience.
Yeah. Sorry, you can go ahead. I was about to say, yeah, it was a really nice. I felt it was really nice to be a part of this event, and there was so much to learn from all the presentations and the children and themselves as well. So thank you so much.
Truly, any judges who would like to give their inputs, we will really appreciate it. Any inputs on how we can improve it, maybe, or any opinions?
No, I think, see, one thing is when you said it is optional, then you should play level playing field that because some of them have gone all the way to DES encryption, some of them have just created very elementary encoding. So somewhere the level playing field was missing.
Yes, so we'll definitely take note of that, and we really hope that this was equally enriching for both the jury as well as the other participants, just as much as it was for the other participants. And yep, I think we have concluded for the presentations. So please give me a minute. I will be redirecting you to the next flow of events. One more minute.